Oh, and my music is broken. Amazing. That is a good start. Well, welcome to the stream. Uh, let me let me quickly fix this. 1 second. That's the bad side. Here we go. Welcome. So, it's also not set up. Very bad start. Here we go. So, welcome. One more week. We are working on the V0. We have a couple of things to do. And I'm actually quite excited for one thing in particular. Hi there, Ravenkeeper. So, lots of random stuff. Basically, two projects, three kind of. The most fun thing will be we will switch out the linear rail for the x-axis. I mentioned it before that I have like a wiggle on the tool head, and I have the very strong suspicion it's the linear rail that has way too much play. This is just a like AliExpress linear rail. It's a RDBB. It's the same that I have on the switch wire, and they're actually quite good from my experience so far. And that's basically very small investment. It's like €10 linear rail. But like just like from the feeling, it's like there's no wiggle at all. Like this is like rock solid. Um, so I'm really excited to just put this in. And I think this will solve a lot of random issues we have with this machine. Firstly, it's obviously that the tool head is not super stiff. So I think this will improve the shaper results, especially on the y-axis where we have quite bad shaper on the y. So let's see about that. And the other thing is like we had this vibration issue in the front of the machine. So basically when the tool is on like the Y0 position, and moves along X, we have this really weird vibration. And I think this has to do with the Bowden tube slightly pulling the tool head back, and then the linear rail just like allowing vibration and play. So very excited about this. Let's see. So my plan here is actually to keep the rail that we have there and just like swap the block. Backup is then we just use the entire rail. Let's just see how it goes. Then second thing that's actually quite cool, also wanted to do it before, but the parts weren't here, so bad luck. We will build a nozzle wiper. So with the Revo probe, with the Revo PZ probe, it's actually quite important that the nozzle is super clean because you use the nozzle basically to probe the bed. So if you have any gunk or stuff on the nozzle, like your first layer is always off. So at the moment what I'm doing is basically I'm babysitting the printer. So I start a print shop, I wait for the nozzle to be like at 170 degrees, and then I scrub the nozzle manually. But I'm a lazy person, so I don't want to sit next to the printer and do work. So we'll build a simple nozzle scrubber. Basically how this will work is like we have this mount. The servo will go in here. Hopefully it fits. It will fit if I put the cable through. So the servo will go in here. And then basically the servo will just move this arm. I think that's like this orientation. So we'll just move the arm up, which will bring this brush head basically in the movement space of the tool head, and then the nozzle can just move through. So we have to do some macro magic there. I think hardware-wise, relatively straightforward. We just have to find like a couple more ports on on the main board to control the servo with. But I think we will find something. So it's project 2, and project 3 is like a minimal side project. I mentioned before that the on-off switch is very sticky. Like when I put it on, like it doesn't quite go in the on position, and then like I get like weird electrical signals, I would say. Like you actually see it on the camera, that the camera goes like into the rainbow demo sample mode. And I think it's just like because there's like some feedback in the AC cable. I have no clue. I'm not an electrical engineer, but if the switch should like switches properly in the determined position, this should definitely help. So let's just swap it out. I ordered actually the whole part, and then I figured out you can actually remove the switch. So I think it's easier if we leave the original part in and just swap the switch. So it's a minimal side project while we work on the machine anyways. Let's do that. But yeah, let's get started. And I think I personally I'm most excited for linear rails, so let's let's start with that. Um, But I think actually maybe it makes sense before we pull the part now, just like to do a shaper calibration now. You generate the graphs for X and Y and then do like a shaper calibration with the new rail and see what that did. So let's just jump in and actually just start with that. I don't know. So, oh, I knew I forgot something. I forgot something. Here, I didn't set up the browser. Ha! Here you go. So, yes, I printed just the parts for the nozzle brush today. Let's just home this bad boy. And actually let me put it on the floor that we get like clean shaper results. Um, Let me put it on the floor. I think that's way better. I really have trust issues when it comes to input shaper on tables. Okay. Because every minimal resonance your table has basically will just translate into the shaper results. So you're kind of measuring the resonance frequency of the printer on the table, but not the resonance frequency of the printer itself, which is what we are actually interested in. So this is what it's doing. We actually also updated Clipper like a while ago, so now it's like the input shaper is doing the moving measurement, or it's moving while measurement while doing the measurement. I guess it generates better shape results because it just doesn't only measure at one spot, but like probes different positions on the bed. Let's see. I hope this doesn't take too long, and I'm very curious actually what it poops out. Like the print quality of this machine is really nice at the moment. Um, it's quite consistent. I do have a bit of ringing, but it's like very minimal. And I'm pushing it quite hard print speed wise at the moment. Does anyone know how much amps the Voron Zero's max? I was thinking of installing a Shelly 1PM mini to it. You mean like amps from the AC, so the total system power, right? You should be fine with the Shelly for sure. Like, you can just check your power supply, right? Like, most V0s have a, I think the BOM has a 150 watt power supply. The LDO kit, for example, has a 200 watt power supply. So with 200 watts, you have pretty much exactly 1 amp. So you will have no issues whatsoever. Yeah, 8 amps is crazy, right? Like you have the wattage is amperes times volt. So I assume you are in Europe. So you have 220 volts. So 8 amps are 2000 something watts. That's like a vacuum cleaner, basically. In the US, it's a bit less because you only have 110 watt, 110 volts. Yep. Oh yeah. I was like very confused because it stopped working, like moving. Yeah, but Shell Mini 100% works fine for that. I actually for a very long time I had like a relay in the machine. Like when I was like using Marlin and Octoprint, I had like a relay in the machine. So basically, the Raspberry was running the entire time, and the relay was just cutting the power to the main board of the printer. I'm Europe, but physics and electric formulas were never my strong point. Me neither. The only thing I really learned, like the only formula about electrics I know is volts times amps is watt. That's the only thing I know, and it's very handy. But yeah, 8 amps is a lot. That's really like a lot. Oh yeah, we now have a Discord server, by the way. The link is in the description. So if you want to join the fun there, please join. But yeah, with the shell, it's actually quite a cool deer. I have, it's not a Shelly, but I have I have from Sonoff, like Zigbee relays. Yeah, I've seen they you just joined. So yeah, I have like from Sonoff, like Zigbee relays, and they are exactly the same. Like all these relays usually go to like 8 amps, I think. That's quite common. because that's usually what like the normal like electrical wire can handle as well. You can do a lot of cool stuff with these. I have way too many in my house. Let's see, it's almost done. Let's quickly like pull the graphs and see. But I can already hear like on the y-axis there's a lot more like noise. So I guess there's more vibration. Let's see, where are we? We are at 120, so it's almost done. Yeah, I'm really curious. Like, because the linear rail is in there at the moment is a high wind rail, so it's technically like a really high quality rail. So it might just be defective. I also wanted to quickly take the old rail apart just to see like if we can spot something that's off. Maybe some balls missing or something like that. Okay, here we go. Let me quickly move this over here. And let me quickly pull up the files. Hi there, Jordy. Welcome. So let's take a look at that. Let me actually quickly share my terminal. Let me share my terminal. That's cursor. Here we go. So, and then I have this very handy command here. So basically it's just like we take the calibration data and generate this resonances Y PNG. And it's basically just running the same thing that's also running like on the clipper side, like automatically. It just generates that image. So actually, it's recommending MZV for Y, which is good. So it's not a horrible result. So it's, yeah, but it's only recommending like 8,400 millimeters per second squared, which is not a horrible like acceleration by any means, but like I feel like the V0 should be capable of more. Let's do the same for X, and then I'll just copy the images into the browser and we can take a look. Let me actually already connect to that machine. Here we are. So yeah, it's also MZV, which is fine. And then we have, yeah, that's the thing. Like for X, we have a recommendation of like 15,500, which is like almost double from Y. And like Y will always be worse, but I hope that we can get a bit closer. So let me quickly pull the two files. Here we go. There's the graph. It's a bit cut off for you, but not too bad. So this is X, and X looks pretty good. Like we have like a nice sharp peak, but this is not ideal. So usually like for the perfect unicorn, this should go down like almost to zero here. So it stays up here. So there might be something loose. I think it's very common to have like a second peak. That's quite common for like any printer, which is like this section here most likely. But yeah, usually should be lower. So this is not super ideal, but the result is quite good. So we have no vibrations here. It's 0 vibrations, and the smoothing is not too horrible, I guess. And acceleration 15,500. So that's fine. Yeah, and this is Y. So actually it looks quite good. That's what I mean. Like usually you expect it to be quite sharp, and then it should go almost to zero. And then you see here there's the second hump that is quite common. Yeah, but like the acceleration is quite low. So let's see if the new rail, like making everything a bit stiffer, allows more here. You see also like here the smoothing is quite a bit higher than on the X, almost double. There's a video on YouTube where someone is explaining how to analyze diagrams and when you know that a screw is loose and such. Yeah, exactly. I've seen the same. there's also like a really cool interview with, I forgot the name of the dude. He's like the input shaper guru on the Voron Discord. And he also like went into like a lot of like details, which is actually quite cool. One thing I took away from this interview was actually EI is like a super acceptable shaper result. So basically, if you have an MZV or EI result, this is okay for like casual printing. And yeah, you're not gaining a lot from making it like the perfect unicorn shape. Reth, yeah, exactly, that's the guy. Reth, Reth, yeah, I don't know how to pronounce it correctly. I think we saw the same video, yeah. But there's also like from I would need to look it up now, but it's also from a very small YouTube channel, like a really cool video over like 45 minutes, where like he goes really into details with all the curves. Um, but yeah, that's it. Um, yeah, so let's just keep this here as a like snapshot. Basically, this is how it was. Let me also quickly just save them in my downloads folder, so we have them for later. And then let's take it apart. Let me be graceful and shut it down before we pull the power. It's something I always try. Like, I always try to like shut down the Linux system um, before you flip the switch. Oh, also, Neo, if you use the Shelly, I'm not quite sure. Like, if you use Home Assistant or something like that, um, make sure to like shut down Linux before you cut the power. Because if you just cut the power to the machine, the SD cards are quite easy to get corrupted. So if you do that like a lot of times, like chances are you corrupt something important at some point. So be a bit careful with that. If you ping me on the brand new Discord, um, I can give you a little bit of like insight what I do with my Home Assistant setup there. So basically what I do is I have let me actually just pull it up. Let me quickly show you. Home Assistant. Oh, oh, no, I would need to remember that. No, let me quickly. So what I have with my machine, so these are, you see Clyde here. Clyde is my printer. This is Clyde. And you see the smart on off. That's actually like not like there's a smart plug down there, which basically is the same as the Shelly. Um, so this one is not a real the switch. It's like a input boolean in Home Assistant. And if I flip the switch, it first checks if the printer is printing, and if the printer is printing, it flips it back on basically. And if I flip it and the printer is not printing, then it first shuts down Linux, and after Linux is shut down, it flips the switch on the real like outlet. So then basically it kills the power. And I also have this like auto power off here, which is like automation, and the automation checks if the power consumption of the machine is lower than a certain threshold for like 30 minutes, and if that's the case, it shuts it down. And I basically just because I work sometimes on the machine, I added like a switch here to stop this auto shut off, basically. Um, I do not use home assistant, but I heard so much about it. Yeah, just do it. Like if you get into like smart home stuff, just use it. It's a blessing of the heavens, basically. It's like you can do a lot of cool shit. A sequence that will first shut down Linux and then cut power is what I need then. Yeah, exactly. That's basically what I built there in a like fancy way. So first, you can just log in with SSH automatically, basically, and like say shut down now, and then you just wait for the connection to be terminated, and then you wait like an extra 15-20 seconds, and then you cut the power, and then you're just certain that the machine is in like in like a shutdown state, and no data gets corrupted when you then cut the power. But yeah, I have that for all my 3 printers, and it's amazing because like basically, for example, if you print overnight, it just prints, and then like the machine cools down, and after 30 minutes, it just cuts the power. It's really handy. Linear rail. It was quite a tangent. So, how do we do that? I think my favorite approach for that would be we just take the tool head off and place the tool head in the head here. And then I would just remove the linear rail basically and just take it out. And then we can firstly just like compare the two side by side, like in a like non-integrated state, and see what's happening there. Where do I have my little bucket? But its machine was printing like a fair bit the last weeks. It was basically more or less like constantly on and printing. Not at night, but basically almost the entire time when I was home. Hi there, on. Man, this screw back there is really difficult to. I feel like with the new canvas toolboard. Let me quickly use the Almaty. Um, got even worse. Okay, here we go. Let's just place it there. And let's take this screw out. And then also like let's just let's do super small ones. Let's just take this out. I have to pay attention a bit with my shoulder this week. I hurt my shoulder a bit in the gym, so I can't have it like too high up for too long. Super annoying. So, the one screw in the back, the hex nut is loose in my printer. To get it back together is a nightmare. Oh shit, yeah. I actually also that plate that where the hex nut is in, I also need to replace that at some point. Let's. Okay, this screw doesn't want to come out. That doesn't really matter. Yeah, I also have to replace this because like there's like we noticed that the motor mount is not like super well seated in here. So there's a bit of a gap, which we need. Yeah, that's future project. Yeah, so thanks. It's not too bad. Like Monday, Tuesday was like quite a nightmare, but now it's almost back to where it was. Got back and neck problems for years now. Oh shit. Also, get well soon. For me, it's luckily only temporary usually, but I do tend to have that sometimes. I do something and I don't like when I do it, it feels okay. And like I don't have any problems. But then like the day after, I feel a lot of pain. For me, it's the tendons is like the weak point for my shoulder. And if I don't pay attention, then yeah, I get that. But it's funny, like now this also feels very solid now. Let me quickly put the screws back. This is weird. Like now, like without the mount, it feels really solid. That's odd. Yeah, no, no, it's no, you can feel it. Yeah. So basically, if I wiggle with the mount, you definitely feel like wiggle. But if I only wiggle on the block, maybe there's like not enough force from my fingers on it. Let's see. Let's just swap it over and see what's happening. But then I don't think we will learn a lot from comparing the two rails while they're like not like on the x-axis. Oh, also the small one. Hi Alex, what X carriage am I using? This is like generic CNC X carriage from AliExpress. We added that a couple of streams ago, because like my tool head was not super stiff, and my thinking was it's the printed X carriage, but then basically turned out it was not the printed X carriage. Let me just grab some zip ties. And all we did with like swapping out the X carriage from the printed one to the CNC X carriage was that we basically made the, let's say, feedback more direct. So it's like more like before it was like a very soft wiggle, like there was a bit of like flex in it, and now it's just a very hard stop basically. It feels a bit different. I'm not quite sure how to describe it. Yeah. Let's put these zip ties here just to prevent the carriage from accidentally flying off the rail. Just checking if I see like large gaps in the balls here, but like this looks all fine. There are some gaps, but not a lot more compared to these. But now like feeling like we still need to grease this. Let's not forget to grease this before I put it in. I cleaned it with IPA, but we did not grease it yet. Like this runs definitely smoother. That's something I can definitely say. This runs smoother. And I'm also feeling it like it feels similarly solid as this one. But yeah, there's like basically you can see here like this just like falls on its own weight, and this one does not. This is I'm not quite sure what it is, but it said medium preload. So technically, like the higher the preload, it means the system has tension basically. So if you have very low preload, you will have very little resistance moving it. But the parts have play, like the carriage and the rail have a little bit of play. And the higher preload basically means you have more friction because like the parts are preloaded basically. So technically this should have less wiggle. Let's see. Let's quickly do a test fit. Before we grease this, let's just quickly throw it on here because I want to feel how it feels with the mount. So let's just quickly throw this on. I'm not gonna worry about like centering it or anything like this. Hi there, Steve. Probably Z0 and Z1 difference on those. Yeah, I think so. I most likely the high one is a Z0, and this is a Z1. The AliExpress listing was a bit dubious, but they said like if you text the seller, they will send you whatever you request, and I requested the medium preload, and also like from just like how it behaves, it's definitely like a higher preload than the other one. I'll just like randomly add some screws here. Really just to try. Yeah, yeah. there's no wiggle at all. This is like rock solid. Yeah, yeah, it's really like a huge difference. This is rock solid. With the other one, like if I pull here, like you can really, I, I forgot to show it, but I showed last stream. Like if you zoom in here on the side on the camera, you really feel or you see how the carriage moves. So this is rock solid. I also mentioned last time, like I checked on the Voron Discord with somebody else who has the same printer, like the same kit, and I also checked with a friend of mine who has the same kit. And both of them said like their X carriage is like there's no give at all. Like it's rock solid. It's the same here. Like this is now like if I now like pull here, I see the rail flex. So I'm not sure if I can show this. So if I let me see if I can convince the camera to focus on this. So if I now pull here, you can see like if you kind of like focus your eyes like on the rail here, you see the entire rail is moving up. So it's not only the carriage. Like this feels rock solid. So that's definitely way to go. So the only thing I quickly want to check is what happens because like the preload is not from the rail, as far as I understand. I'm not 100% certain on that, but the preload comes from the carriage. So I want to quickly check what happens if we take our nice high wind rail and just add the RDBB carriage on top of that. But yeah, this feels a lot better. Let's quickly pull this out again. And before we put it in like for real, we also definitely need to add grease. Yeah, but I'm very happy with this already. Like this already feels a lot more solid. So I'm really curious what this does with our input shaper then. I could imagine that on X actually might hurt a bit because there's more friction weight. Nobody saw that. There's more friction. But on Y, I would assume it gets a lot better. Let me just quickly park the cable down here. Okay, let's zoom in on action here. So this is the new rail. As I mentioned, it's the RDBB. You see the laser engraving here. And that's the high wind rail. So that the rail itself is a lot nicer. Focuses. Has the laser engravings here. Like the color is like nicer. So I would prefer to keep the rail. So let's do the following. And I'm risking everything here now. Let's try to move this carriage on this rail. Let's see. Actually, I will remove the zip tie here because I want to have the rails flush with the table. And then technically, I should be able to just slide this over. And you see the black block here has like a lot more friction. So I think we can safely assume that if we now put this on the printer, we will have the higher preload. And then let's do the magic again. Perfect. There's relatively low risk we accidentally lose this block. So let me just add these stoppers here to the other rail. Let's quickly clean this bad boy. I quickly want to see the engraving. Maybe it says something about the preload on the laser engraving there. Yeah, it's like hardened thread locker on there. Oh wow. It's getting worse instead of better. Let's just let that soak for a second. In the meantime, let's grease this bad boy. Let me quickly grab. Oh god, I think I have these all the way in the back. Perfect. Okay, this is a later problem. We actually talked about the grease like a couple of streams ago. So this is the Mobilux EP2 I'm using. And usually how I do it, it's quite a messy way of doing it. I just move the carriage over one of the holes. And then I put the syringe on top. And then just press it in. And then you see like left and right, it like squeezes out. And then you know like your block is fully packed with grease. And it's quite messy because now you have a shitload of grease on your rail. Neo, I'm not quite sure if I can follow. I do it that way as well. Oh yeah, yeah. I think it's quite a good way. It's just like you have to clean the rail afterwards. It's also like very wasteful because I think like maybe a third of the grease like you use actually ends up in the carriage. But the benefit is you don't have to pull the carriage off, which yeah, to be honest, is not the worst thing you could ever do. Like if you're careful with the carriage while it's off, it's totally fine. I was actually checking how much like a high wind carriage is. It's like super crazy. Like for one, like for the I paid like 10 euros for the entire rail. And the high wind carriage is alone, just a carriage without rails, like 30 euros. Like super crazy. And that's the worst part. You have to kind of like clean out that screw hole you used to inject it. Yeah, it is a bit messy, but it's a very easy way. It is easy, yeah, Neo, you're right. And taking it off might end up with losing these metal balls. Well, if you're careful, you can do it. It's not too horrible. Like you need to be careful, of course. I've done it like not too often, but a couple of times. And let's just say like with these MGN7 rails, it's also like especially challenging because like everything is so small. Like I feel like it's easier with the bigger rails because you have a bit more space in the holes. Okay, doesn't need to be perfect, but I don't want to like put grease everywhere in the machine. Cool. So following, let's get rid of this greasy paper towel. I still want to do a quick like post-mortem of this rail here. Just curious, like what exactly it is. So this is the rail that came with the LDO kit here. And there's like so much stuff here, like I can't read the. So there should be a Z. So it's like reading here from the laser engraving, it's MGN7 C05B2103. Let's just quickly punch this in Google. I just want to see like what the specs are. So this is high win C05B2 103. Let's just see what pops up there. And what happens if I do this without Highwind? Then we don't get any results. So I don't think this is like a serial number, like a product number or something. So I'm not quite sure what we are looking at here. Also on the back, there's like no preload information. So I'm not quite sure. Like I checked the BOM of the LDO kit, and I think it was supposed to be a Z1, but not quite sure. So let's just leave this maybe for a future project where it's not as critical. Like this would also be like a nice rail for Y or something, where you have like two rails, so it's like less critical. But the X rail is always like the most important one. Cool. Oh, let's get this back here. The new Discord pop up on screen. Yeah, I just quickly built this like just before the stream now, so it's quite a rough, quite a rough animation. And I also saw now like I'm a bit sad like when it shows up and it like animates in, like it's not fully transparent on the background. It's like there's black, which shouldn't be there. But yeah, can't have it all, I guess. Okay, let's just actually we need the um, I have these like little printed helpers somewhere in here. Here's one. Just to keep this nice and centered. There should be a second one here. I know it's there. But it is hiding. Oh yeah, and that's the printed X carriage we removed. It technically worked fine, but like my hope was with the CNC carriage that we have like a more rigid structure, but then like it turned out that it didn't do a lot. Because the cause was not the mount, but the rail. Okay, so let's just center this, but I think also like with the CNC, because we are kind of fully CNC now, like we have the CNC XY joints, we have the CNC X carriage, and we have the lightweight CNC X beam here. But I think with this one, because the screw holes are like not like a nut, but like it's like properly like drilled holes. Wait, let me check that I'm putting this in the right one. So let's just start from left and right. Because it's like a drilled hole, I think it's already precise enough. You don't really need them because there's no nut that has play. It's always perfectly centered if you screw it in with these pre-drilled holes, basically. We can already remove that. And then I think we just always skip one, and then in the center there were 2 screws. Yeah, so we now have these 2. I really like these RDBB rails. There's this one shop on AliExpress that sells them. Oh, we actually should add some thread locker there. That I got that originally from the switchwire, from the original switchwire bomb. And from switchwire, they were really good. So now I decided to just also get the same ones for the V0, for the X here. And also like a really nice rail. I mean, let's see how it behaves when we print with it, but so far it seems to be like a clear improvement. Let's put this one here. You don't need a lot of thread locker here. It's just like I always just put a dab on some plastic or something, and then I just like quickly touch the thread locker with a screw, and then it's like already plenty. Especially with the ABS parts, like if you have like a printed carriage, you need to be quite careful to not overuse a thread locker, because the thread locker will like attack the ABS, basically make it weaker in that spot. So rather cautious amounts. For me, I have CNC parts, so I can kind of like sprinkle it everywhere. It doesn't really matter. But yeah, be a bit careful with ABS parts. Cool. That's all back together, and like yeah, it feels so much better. It's not even close. Let's try to get this back on here. Oh no, we didn't put the. Oh, that will be fun. We didn't put the magic screw in. Let's see if I can maneuver this in here. This is the red one? No, it's the longer one. Yeah. Yes. Success. My problem is more like tightening everything way too much. Yeah, it's also something I tend to do. The problem is also with the plastic parts. If you over tighten it, the plastic will like creep a bit under the pressure over time. So basically, if you put it too tight, it will get loose. And then you tighten it again, and then you put more pressure on the plastic, and at some point you just break the ABS part. That actually happened to me with the switchwire carriage. I now actually also have a CNC carriage there. I think like if you don't need CNC parts at all. Like if you have any, if you need one CNC part, for me it's always the X carriage makes the most sense, I think. Sure, it's somewhat tight. Oh, okay. Double check that we tightened the center screw here. We did. And then we quickly have to tighten the 2 screws on front, and we are done. Yeah, so that's a bit of flex, but like it's way, way less. Like if you really pull on it, like, yeah, sure, it flexes a bit, but it's way less. That's clearly like improvement. Let's do the following. Let's input shape that. And while it's input shaping, we quickly take apart that other linear rail. I'm just putting it down. Let's make sure it's not standing on the cable. And let's please wait for it to boot up. And all Metal Voron, that's what I need. But not only a V0, but a Trident or 2.4. Well, it's getting quite expensive. Like, I mean, the parts exist, right? You can buy like the 2.4 and Trident CNC kits. It's just getting really expensive. I have the 2.4 all metal, runs a lot faster than the stock Trident. Yeah, I bet. Like, it makes a huge difference just like from the stiffness of the parts. It's just like if you feel a plastic part, like it feels very solid. But then if you put a metal part next to it and you also try to like work with it, like it's just like, yeah, it's metal. It's like completely stiff. Makes a huge difference. But I think like for most printers, the printed parts are fine. So just for me, like I feel like the most impact has always the X carriage. Or like always. My sample size is 2. But it has quite a big impact. So let's quickly home that. Remove this over a bit more. And we can shape or calibrate. Oops. You can buy the metal parts Voron 2.4 on 3 Jake, but costs 450 euros. And the Voron kit itself costs 1,500. Well, if you go with the LDO kit, yes. But if you, for example, go with the Formbot or Physect or Seabor kit, the kit for 2.4 is maybe like 800 euros. And then if you add the metal parts, you're like 1,200, 1,300. So it's just like the question what you want, right? I mean, the LDO kit then will have, for example, nicer hot end. It will have like nice electronics a bit and stuff like that. But then it gets more expensive. But you can kind of like, pick and choose in a certain sense. You could also do like a fully self-sourced kit, right? And then you have even more control of what you spend the money on. All right, but just like for like science, let's just quickly pull off the block here. Not much to lose, right? It's kind of like a bad block. So, I mean, you can always just carefully slide it off and it will be fine. So basically you have these like metal bars here that hold the balls in place. And when you slide the rail on, basically, like you see like the groove is where the balls go in. So you just need to be careful to align that properly, and then it's no biggie to pull this off. You also see now, technically you could also like grease it now here. I never did that actually, and I would be a bit scared because now you add like mechanical pressure basically with the grease on the balls, so I would be a bit more concerned. But technically, even if you lose the balls, you can put them back. I think with bigger rails it's easier than with the MGN7 rails, but it's definitely possible. But looking at that, they're like relatively large gaps, and there are supposed to be some gaps, but I'm not quite sure. Um, I really don't like this Discord animation. That's something I have to change. Um, it shouldn't be that many. So you see here, like basically like this groove just interacts with the metal bars. And then you just carefully slide in. Oh, and I actually lost the ball. Oh, ha! I did it before, it was fine. Here we go. How to destroy carriage live on camera. That's like a lot of gunk here. But yeah, you saw like you can really just like put them back. Just be careful, like don't put pressure on it, because if you put pressure on it, like the balls will go like everywhere. Here we go. So it's definitely doable. Just be careful. Like don't put pressure on it. That's the one thing. Like don't force anything. If you feel resistance, stop. It's like quite good advice for a lot of things. Um, LDO kits are so nice. I like the boxes of the organized parts. Yeah, it's actually I do have another kit coming. And I took a sneak peek into it, and it's also like quite nicely organized. I'm actually like from the V0 kit, I wasn't like a huge fan of how the hardware in the LDO kit was organized. Because you had like multiple like bags with like M3 by 8, for example, and it was like really messy in a certain sense. And like one bag was empty, and then you were looking for like another bag. So yeah, not a huge fan of that. But overall, like I think what the LDO kits have, like the biggest benefit for LDO kits is the manual. Like the documentation that comes with LDO kits is amazing. And I think also the support is really, really good. I had a defective motor and a defective cable on my kit. It was like a real like breeze to get like the replacement parts, and that was like via 3D Jake from LDO. So that was really good. So I think that's what you pay for, is like the service and the documentation, and then they have nicer parts. Like for example, like a high wind rail. The cheaper kits would not have a high wind rail. Just buy some new bearings for it. Measure the size of the steel balls. You can buy them, make it as good as new, cheap. Oh, you mean here, like to add new balls, Steve? I'm not sure. Like I'm really certain we did not lose balls. Like I'm really certain we did not lose balls because I never pulled this carriage off. Um, there are gaps. I'm not quite sure if they're supposed to be this big. Like we would need to redo like side by side comparison, I guess. Um, but yeah. Um, I always use the plastic part that comes with the rails to take off and on the carriage. Yeah, it's also like it's basically what I did now with the two rails, right? Like where I put the rails next to it and then you slide it over. That's exactly what the plastic parts do as well, basically. Um, what's your next kit? Well, you have to wait 1 week, Alex, then you will find out. um, they could be worn. You replace them all. Oh, so you mean like as maintenance? Should they be worn after like I mean we checked last time, like right, it's like 800-ish hours of print time. I wouldn't expect them to be in need of replacement after this short of time. Okay, we have an input shape complete. But it would be like a cool thing to do on stream, Steve. Like linear rail operation, open heart operation, replacing walls. It would be actually quite cool to do. Like I would be interested to just try it out. And the thing is, like, if you have a rail that's not good, what do you lose, right? Let me actually plug this over here for a second. Mm, then terminal time. Oh, that's Orca. um, we will need Orca in a second, so let's leave it up. But here we go. I don't want AI, please. I want SSH. Oh, I think this is toasted. Let's quickly connect again. So we just do X and we do Y, and then we will see. This X. So I would expect X to be roughly the same. I actually got a bit better. Yeah, so we get an MZV shaper. And before we had 15,500 on X. Now we have 16,000, so it's a hair better. the smoothing was 0.04, I assume. So smoothing is also like about the same. So on X, not much changed, which is good. Let's look at Y. Ordered some rail for the makerspace. They arrived with a bag of extra balls. Yeah, actually, the rails for the switchwire also like came with a bag of balls. So I assume they assume you will lose some. Yeah, like my expectations, why would change more? Let's see. So you get an MZV. Ah, I mean it's not on par with X, but this is like over 2,000 or like around 2,000 improvement. So that's actually quite a good improvement. Um, let's quickly like let me quickly like load the images. By the way, how I do that? Um, I one thing I always install on my Raspberries that are inside the Clipper machines is Samba. Samba is like a file service. So basically, if you have a MacBook, for example, or Mac, also on Windows, the printer then just shows up in the network environment in your file explorer, and then you can just like open files there. So it's like super handy. So I can just like quickly copy over the files, and like if I have to compile something, or yeah, you can just copy files back and forth. It's like super handy. So let me quickly sort this. So these are the two X's. So it definitely changed on X. Oh yeah, here we now have this like, oh, sorry. Here we now have this like tiny second peak that's quite common. So like definitely the curve changed. It's not ideal. Like if you want to have like a true unicorn, you need to do some work here, I guess. But it's super doable. Like just like from the results we get. Yeah, you see the smoothing didn't change at all. So 0.04 on both. Just like here we have 16,200 and here we have 15,500. So it's a tiny bump. Like yeah, it's not what limits the machine. Let's check Y. So this is the before. So we have smoothing is 0.07, so like almost double what we have on X. And acceleration is 8,400. And the curve looks actually worse. You see here, there's now this hump. But it could also just be because now it's the system is stiffer, so like it transfers those vibrations better. And we have recommended MZV with 10,200, so it's like 1,800 improvement. And smoothing is like that much better, but I guess it's like, yeah, you don't really need it. The frequency also changed a bit, right? Like from 53 to 58. Here we are 74 and 72. So like on X, like yeah, less change than on Y, but it's pretty good. I would say it's a solid improvement. The only thing we now didn't do is like before we made the change, it would also been interesting to like do like acceleration tests and see like, because like the rail now has more resistance. What it does in terms of the max acceleration we can actually use like from a hardware limit. But I assume like that we are with that super like in line now. At the moment, like let's just check my Orca profile. Oh, I need to set up the sharing for Orca. It's fun how like OBS like every time just grabs like a random window to share. Here you go. This is my Orca. Don't look at the projects too much. So at the moment what I'm using is speed wise. Yeah, so I'm using like 7,000 acceleration for normal printing. And yeah, for infill 12,000, and like the speeds are quite high. But it's basically like the limiting factor usually for me is then the flow, because I kept the flow at like 15 cubic centimeters per second. No, it's not the right unit. Cubic millimeters per second. Cubic centimeters would be crazy. So I kept it as 15, depending on the material of it, and that's usually what limits the speed. need to run it again after printing while and let the rail bed in. Yeah, we should definitely like move the printhead a bit. How about we pre-print like a quick Voron cube or something? Let's actually first do the nozzle brush, but then let's do some printing later. I think that's like already like massive success. I like that. Like we were kind of like slowly making up for like the massive failure that was like last week's stream. So then let's just turn it off again, I guess, because we need to do some hardware work. So let's just let's save the config. If you print a VFA calibration test, you can check on which speed your quality looks best. And then you can use these speeds for your parameters. Yeah, I should do that. I didn't do it yet. But to be honest, like the print quality is, I'm more than happy. Like I'm not like an absolute perfectionist. The first layers look very good now. They're consistent with the nozzle probe. Let me just quickly grab a part I printed this week and then take a look. So this came off the machine with the settings I just showed like this week. The first layer is very good. Like you see the lines a bit, like I had it a tad high, I guess, but this like really nice first layer. There's no elephant foot or something. And the pattern now also hides defects a bit, I would say, but there's no noticeable ringing or anything. Like this is like a really solid print. See like here a tiny bit of a shadow, like of lines, I guess. But it's, like I would say honestly, like this machine never printed as well as it does now. Of course, you can always improve it, but I'm very happy with the parts that come off these machines. For example, I use external parameters with a speed of 40 for PLA because then it's not matte finish and looks best with slow speeds. Yeah, there's actually like something for materials, right? Like that the print speed also like determines how the material looks. For me, what I do is I have do not slow for outer walls. So the outer wall always has the same speed. That's quite important for me. What I do is I slow for overhangs, which then technically also would slow for outer walls. But yeah, so I try to keep the wall speed consistent. Um, what a hint at the next build. Yes, it's a hint, but it's I picked it specifically that's not like a big hint. That's great marble filament. What filament is that? This is amazing filament. Like I'm so happy. I got it recommended just a couple of weeks ago. And this is the Nobufill ABS-X Marble White. It's really nice. Like it's really nice. I'm a bit concerned because it's like not a clean filament and because it's like white in the base color. I'm a bit concerned about the mechanical properties because I learned that white filament, white ABS is weaker than other ABS. And then of course you also have the black sparkles in there, which might weaken the part. I don't know. I decided to bite the bullet. Just go with it. It looks amazing. Like it's the first time I actually bought an overfill. And it's really nice filament. Like it prints like a dream. Like the ABS prints like a dream. I have this marble white. I also have the black. So for this project, like it's all Nobufill. And I have the matte black. It also looks really nice. I mean, it's black, but let me see if I find like a part that doesn't give away anything. Oh yeah, this one. This one. this is like not a hint. I just looked for like some functional parts to do test prints with. The black is also the Noble Fill ABS matte black, and you see like here's a bit of ringing, also like from the V0. And the green is also the Noble Fill. I don't know the color. It's like lime green. So it looked really nice. I have a ballistic tech. Catching up on the stream in twice the speed. My understanding of the preload for these types of rails is that the size of the ball bearings relative to the channel. Lower preload is smaller, higher is larger. Yeah, exactly. So basically, if the preload is higher, you have like basically more or less like there's no like less play. So you just have like more of a friction fit in a certain sense. So yeah, there's less play. The best one I use regularly is Patchy Matte Finish from Fiberology. Looks so good. Can recommend. I will give it a shot because I have some Patchy project coming up. I want to print like in my office we have this like living wall. Like this sounds more fancy. This is basically just like plant pots on the wall, and like the plants kind of overgrow the pots and looks like just like plants coming out the wall. I wanted to have something in my living room like that, and it's super expensive. Like it's just like plastic parts that you like screw to the wall. But like, for some reason, like if you want to have like a decently sized wall, like 1 by 1 meter or something, like you pay like 200-300 euros. It's super crazy. So I decided to make my own. But then basically because like water is involved, I don't want to print with PLA because PLA is quite bad when it comes like if PLA is moist, it's very conducive to mold. So I want to use patchy, but I really hate patchy. I hate printing patchy. So I'll give it a shot because I didn't find a good patchy yet that I really like. A higher preload can cause higher wear and increased temp. Yeah, I mean it has more friction. Like the higher the preload is, the more friction you have in the system. So it's more heavy to move the part, but it's also more precise in the motion. So I was checking online, and the recommendation for preload is basically the medium preload for X seems to be ideal, and this is what this is. This is like a medium preload, so the Z1 preload. And for the other rails, you can use Z0, so the light preload. Higher preload with two rails makes parallelism much more important, easier to bind with higher preload and unpaired rails. Yeah, that's also like something, right? Like the more restrained the motion is in directions the motion is not supposed to happen, the harder it becomes. But if you have like a single X rail, I think like the higher preloads make a lot of sense. Let's see how it performs. Cool. Yeah, but it's kind of like the tension. So I think it prints really nice. I'm very happy with this machine. And we are kind of like tweaking to make it a bit better, but it's like quite good already. Cool. Let's work on our nozzle wiper because that's just like a quality of life improvement that I'm really looking forward to. And there's already like so much dirt already again the machine. Like, it's incredible. Let's put this all the way down. Okay, so let's see what we have here. So we do have one of these servos. They're like super cheap. I bought quite a bunch now. I am wondering because the cable will be too short most likely. We also need to find a way to like sneak the cable to the back. But basically this will just go on like this. We need to check the printables page again in a second. But I think this just goes on like this, basically here on the side of the rail. And then we have this little arm basically that we attach to the servo. And this will just, well, it should move. Okay, we have to screw it in, otherwise it doesn't move. But yeah, so that's basically all there is. And then on this like surface here, I actually bought new brushes, but they have a curved head, which I didn't see in the listing. So we have to use my old trusty brush here and just tape this here and like obviously cut off the handle. And then we will have a very nice nozzle brush. Um, some of the rails at the shop I interned at had adjustable preload, which was cool. Oh, how does that work then? Is there like a screw you tighten to like squeeze the balls further in, or like how can you adjust the preload? Servo brush, yeah, we need a servo brush. Cool, yeah, I would say let's first figure out how we run the cable, because that will determine how long the cable needs to be. So let me also quickly like remove the filament, then we don't have that flopping around. We did shut it down, so let's pull the power. And let's quickly start by taking off the panel. Oh, I wish we had like magnetic panels. At some point, maybe we will have a success. It's definitely still on my to-do list to have magnetic panels. It's not high enough up my priority list for now. Yeah, and I see our like LED disaster still here, so that's also something for the future to clean up. But not so important for now. Okay, so let's also quickly check the pin out of the board. I think we still have that open here. So we do have some ports left. It's not a lot, but it's some. We need 5 volt, we need ground, and we need a data pin. And I think we could use this here, these 3 that looks like... Oh, this is 24 volts, so we can't really use that. This is technically the official servo pin, but we kind of misused that already. Let me see. We could... It's always like the ground is always the issue. Technically, we can use up here. We have a 5 volt pin still left. Here's 5 volts. We have 1 IO. We don't have a ground, so that would be... Because like there's only 1 ground pin, and this cable here already takes the ground pin. What do we have here on the side? The X stop and the Y stop are obviously taken. So these 2 are taken, like not physically taken, but basically because we have the jumper here, they can't be used. They do have ground at 5 volt though, so maybe we have to do like, because like the board is pretty full by now, maybe we do have to do like one of these fancy split connectors where like, for example, we can use the IO pin from this connector and then grab 5 volt and ground from here and then like move that together. So I think that's a valid solution here. Let's just use the IO pin from here and ground and 5 volt from here. Then we need to figure out how to run the cable to the front in like in a nice way. Let's see. So there's a gap just below the extrusion here. So I think we can kind of like just push some cables through there because that's exactly where we need it then. It's just here. So the question is also, let me quickly cut off the plug because the plug we can't use anyways. And looking at this, it might be long enough. Let me quickly actually open that printables project. We quickly can check like how this is supposed to be used. So I also have the link in the description for this one. Let me quickly kill these. So this is the project we have here. So it's quite straightforward. This is basically what it does. The only thing we need to do, like when we write the macro in a second, we have to move the bed down so that then the brush can flip up. There are some others that don't need the bed to be all the way down. They basically flip the brush like this, but I have the Nevermore there and I wasn't quite sure if that would be okay from a clearance perspective. But yeah, we can already see like how this is supposed to be mounted. So the cable really comes out on top. Let's just see if we can push the cable through here. So there's really not a lot of gap. I think we don't have good chances here to really push it through. I'm not quite sure if we can. Yeah, we do the same with the flatband cable of the camera, but then of course the flatband cable is quite flat. So I think it could just work. Otherwise, we have to move the cable here to the side, but I don't want to do that. So it doesn't look nice. Technically, we could also drill a small hole. And I'm trying to push the plate a bit to the front. And that's not easy. They will pinch if the printer vibrates. Drill a hole. Okay. Okay, Steve. We drill a small hole. I think it should be quite easy. Let me grab a drill. 1 second. I'm right back. That was not on my bucket list, but we will drill a hole. And now my music got killed off again. Okay, let's first do the drilling. There are some modified versions of the Bowden inlet frame PCB piece. I've seen a lot of people passing wires through them. Well, I have actually my own one. I made this a couple of weeks ago, but I don't want to do that because if I would use this for that, I mean, it's easy to do, right? It's just like then you have these like rainbow colored cables like flying around in here going up there. I like it clean. So preferably I will just have the hole here exactly where I have it. But before I drill a hole then, let's quickly check at which height we actually need that we get like somewhat in line here. But I think it needs to be quite high up actually. So if we drill the hole just like on the top here, just under the top extrusion, it should be fine. Maybe let's also quickly glue the... I'm not quite sure if this will work actually. We might need to have some other tool to... Oh yeah, it works. Okay, well, okay, that was easy. Okay, we can clean this up in a second. I just want to see like how how tall it needs to be. So if we add this here, just holding this. Let me see if I can give you like an angle on that. So if this is as low as it goes. If I add this here, so definitely needs to be relatively high up. This is quite some. So technically it needs to be somewhere around here. We need to have the exact height later, but like I think this is somewhat of okay height, so that the brush basically just touches like the flat part of the railway nozzle here. So somewhere here. And if I just hold this here, you can see basically we are basically on top of that black panel here. So I would just drill the hole really like here in the corner. And then looking at this part, maybe what we can also do is we can, not sure if we weaken that a lot. Now let's keep it in one piece. I was thinking of adding like a small cutout here on the side to pass the cable through, but I think that might weaken the structure too much. So, oh, don't touch the camera. I would guess like a 3mm hole. I need to like secure the cable a bit more. It's like something when I touch it, like sometimes it goes in this rainbow. If it's really if I touch the cable that goes into the camera. Okay, let's make sure there's no cable behind. And I think we need to we need to move the camera behind. I already checked what's behind the spot, Neo. There's no cable. No cable here. There's like a nice gap. It would be really awkward if I drill into like the mainboard or something. Measure twice. Yeah, that's always what they say. But here's I feel with my thumb. I feel the nut, the screw head that holds this extrusion. And next to it, there's nothing. So if we drill here, we'll be fine. Now we have a very beautiful 3mm hole. Moment of truth. We hit nothing. I mean, you can't see it, but there's the hole. All nice. Actually looks clean. Very happy. Let's see if 3mm is enough to pass the cables through or whether we need to make it 4. Yeah, but it should be fine. If I manage to put it in. Let me quickly move the camera up that I can get a bit closer. So it's really awkward to like it's like so close to the extrusion. Yeah, it's just a good size. Actually, maybe we should make it 4. Maybe we should make it 4. Just like there's a bit more wiggle room. Let's quickly drill second time with 4. Now it's 4. And I think with 4 it should be easy. And then we also have like a bit of like adjustment here with the height where we want to put it in. So that's quite good. Okay, I'll call it a quick big success. We drilled and we did not destroy anything. Okay. Then let's see if the wire, hopefully the wire is long enough. Maybe let's actually quickly fix this here in place. I think we still have plenty of nuts. And I also have quite a lot of the no drop nut mod. Just have to find one that's a good good dimension, that it doesn't like fully slide down on just like terms of gravity. Yeah, that's good. I think we need to use the LT here because it's a bit tight. Okay, let's see. I think we have to move it quite a bit down actually. This will be really awkward. I don't want to take off the side panel because I'm lazy, but I'm not quite sure if this is quicker without the side panel or not. What type of screw do we need here? Just like a normal button head screw. And I think we still have like 1 and 3x8 just flying around here. Yeah, this will be really awkward to put in because I can't really put it from the side. Let's also first screw this one in here. That would be also like a very good first step. We should have a couple to self-tapping screws. The 560 profile did not support no drop knots. And so many slide out while building. Oh god. Why does it not support that? Like is extrusion different or? That sounds horrible. Oh, and these are Phillips heads. Like basically, as soon as you move the extrusion, like all the nuts slide out. It sounds like a nightmare. Let's try this one. Oh wait, these are also 2 different ones. The heads are different. Let's pick 2 that are the same, just for like aesthetic reasons. So, oh, yeah, now it's also imbus. So I have like a random wrong screw in there. Well, too bad. That's too small. That's a fit. Okay, that's number 1. Number 2. And now the tricky part. I'm not quite sure yet how to do this. I don't think I have like... I have this like really short Allen key, but it's like too big. I do have a short one here as well, which fits, and that might just be enough. Oh yeah, that is good. And I think I can kind of see from the side here what I'm doing. That's the joy of building a V0. It's like everything is really tight and really small. I think it's grabbing. Yeah, it does. Ooh, perfect. Let's move it up a bit. As we said, it should be quite close to the top here. We have to later like make this fine adjustments. It's a bit annoying because it doesn't have like a ball head. Like I have to can only do like half turns. Oh no. We also need to screw in the arm. Okay, let's fully assemble. I thought about like I don't want to put on the arm yet, because if I put on the arm, we need to be careful how we control the servo because like the arm of course could collide. Um, okay, let's. Fully loosen this. Because there's also a screw here. So the problem is this is a bit not badly designed, but basically this is designed to directly like go onto here. But it doesn't have the teeth, of course, of the servo. So it's like it doesn't have like a lot of torque. Let's quickly check that little bag with the servo because they always come with these arms. If they only had magnetic panels, yes, I wish. So I just want to see quickly, like, why is this so hard to turn? Usually you should be able to turn the servo. I don't like this. Usually you should be able to like move this by hand. And you can't. I don't like this one. Let's use a different one. That's why you buy them in 10 packs. We have plenty more. But not crazy, right? Like you should be able to, you have to be able to move this by hand. No, no, Steve, this is not the one I broke. They are brand new. I actually ordered them. I was waiting for them to arrive. Okay. Yeah, see? This one works. So this one is this is the like end position. And this is the end position. So if we position this like facing downward, this is fine because basically we all need 90 degrees of like movement, right? So if we can move it in this range, it's fine. Just like if you would, for example, like position it this way, you can't really, you don't have the motion range necessary to like move it down, right? And this would be the end position. So this position is fine because then we have it down and we can move it up to 90. So that's perfect. Okay. Well, let's get it out of here. This is weird. I mean, like it's a €2 AliExpress servo, so yeah, just like it locks up internally, like you can't turn this at all. Okay. Well, we tried. We tried. Where's my little trash bin? Yes, it's behind the printer. And out it goes. Well, let's try this again. Well, fully planned. All things that side panel is coming off before this is installed. Steve, I think yes, it will come off before this is installed. It's one of these things where like I really try to prevent doing extra work in terms of like moving off the side panel, but in turn I create so much extra work that it's just quicker to take off the side panel. Okay, so we said this is aligned, right? Let's just quickly double check. So this is fine. So if we now install it facing downward, we are golden. And just like to double check, this is supposed to go like this. And this is supposed to be like this. Yeah. And this is all the way it goes in. So like you see the gear here a bit. This needs. Oh, they come with screws actually. Oh, it's like that's exactly the screw we need here. Okay, well then let's make use of the screw we got. Also, center is Phillips as well, anyways. So, by the way, it's focused. The camera is focusing on the printer here, right? It's not focusing on what I'm doing. No, it does. Okay, that works. Then let's quickly swap these screws for the ones that came with the servo, so I don't have to use my nice LDO kit screws. And can keep them for something nicer in the future. If they say on, they might have scratches. I pay attention. I actually did. I cleaned the head panels this week because there was like a lot of like gunk inside, and I scratched the panels on top with the cleaning sponge, which was like quite a fail. Okay. I am fairly certain I can do this. I know you don't believe in me, but I believe in myself. Let's quickly run the wire to the back. Go in there. Okay. That is. Where's the wire? There we go. And then that is here. Let's actually move this quite a bit down. That's like easier with the cable. And I think this is already it. That's it. Just have to do half turn to fix it. There you go. Perfect. Let's quickly clean this one up. I have like a beautiful new cutting mat because I was like actually discovering already 1-2 scratches on the tabletop. So I figured it's like worth investing in one of these again. I know you don't see what I'm doing, but a bit hard to do it in the center. This is quite good. I actually wonder if you can buy these like brush heads like separate. And then let's which way do we face this? Like this is the ugly side. We can face the ugly side to the back in this way, but then it's on the top in this position. Let's face the ugly side to the front. That's like in the stowed positions on the bottom. And then we need some VHB tape. Let me quickly clean up here. I keep this bag with all the sealed goodies, and this all goes to the trash. Steve, you lost your bet. Panel did not come off. Yet, to be fair. Okay. Then the other fun part is now, we didn't actually check, I just assumed, is the cable long enough? The cable is long enough. So we can actually, it's a bit too short to be run through the cable channel. So that's not nice. Oh wait, we wanted to put it here and here anyway, so then it's a good length. We'll manage that in a second and crimp and do all the fun part. It's a Wago of shame. I'm actually having a plan for the LDs. I actually wanted to do it today already, but I didn't have time to find or create the needed parts. I want to remove these LED bars here on the side, and I want to move them into the head basically. So like here and here, like on 3 sides. That's like from the top. That's my plan, and then I want to use different LEDs, like daylight LEDs and not RGB. I still have no idea what the reasons is. I actually gave up. I kind of gave up on that. Like it's not worth my time to figure this out. Not worth my time. Down where they are now, they help the camera. I think also from top they should help the camera fine. The only reason or concern I have with putting them on top, so why I want to put them on top, I think it's like a nicer placement. The only concern I have is that basically the tool head will create a shadow. But then you also have the LDs on the bottom of the tool head that should like eliminate that. So I think it should be just fine. I'm trying to press this down without like poking like brush wires in my hand, but I think this is fine. Okay, that is in. I was like briefly considering to throw this up there, but this can only go wrong. That's on tool head. I forgot that. I do not. Yeah, absolute game changer. Like I have the same tool head on the Poorman, I don't have LEDs there yet, and it's a disaster. Like, I'm really annoyed because like you cannot see what the printer is doing because like there's always the shadow from the printhead. Even if you have just like light on and like the printhead always throws a shadow exactly on the spot I want to see. So like these LEDs are absolute no-brainer for me. They're actually super cheap. I actually bought like 4 more with RGB from AliExpress the other day for €2 for a future project. But yeah, no brainer. Just get it. A bit of a pain to install, but afterwards, like it just works amazingly. Yeah, so this is a bit too high. So I'm now like, we are now, if I show this here, yeah, the one problem with this camera arm is like it doesn't go lower than this, which is like not quite a V0 height. So if I lift this up a bit, which is great with my shoulder, you see it's like just like tad too low. So I think we have to move down like half a centimeter or something. Oh, we could have. Uh, Let me see. Definitely this needs to go. Here you get like first row perspective on that. Let me not tighten that yet. Let's just quickly check. It's still a bit high. I think this is a good height. Now it's just like, I mean, I just have to prop it up a little bit because it will stay here at 90. Yeah, I think this is a good height. Let's use this height. Okay, I think it's already fixed, just like for good measure. Yeah, perfect. It's actually quite okay. Okay, then let's do the wiring. So, brown was ground. Let's put the. We want to ignore this Vago. Brown was ground, red is 5 volt, and the yellow wire is the signal. So basically what we need to do is the yellow wire goes here and the other two go here. So it's kind of twofold. Let me just quickly double check. Motor pin, just to keep my sanity. Brown is ground, control is yellow. So we split these two. And maybe let's try to get them under all the other cables, which would have been easier to do before pulling them apart. Here we go. I'm really asking myself how the sequence will look like, because I retract the filament so that I can yank it out if the printer cooled down. But even when the nozzle gets hot, it oozes filament. Oh, well, for me, it's actually quite okay. I think the trick is to like not put the nozzle to like the printing temperature. So what I now do with my sequence in the right now, basically, I heat it to 170 degrees. That basically allows the filament to be like a little bit soft, but it's not like flowing. And then only at the end, like when the bed is like leveled and everything is ready, then I heat the nozzle to the printing temperature. I think that's the important part, that you don't um, put the temperature too high too early in your start print sequence. I'll leave the cable a little bit long that we can have like easy time crimping it here. And I need my trusty crimping box. So the yellow one is the hardest one because it's relatively short in here. Smart people would have crimped before putting everything in, but I do not qualify for that. Here we go. And then for these, so this is basically for here. And then maybe we can just run this briefly into this cable. Oh, by the way, we forgot to close this last time. So over here, there's the cover for this cable channel. We should add that. And then for here, something like this. So we can snip off something like that, and then do 2 crimps. Nozzle always hit printing temp for the slicers, then cools to 170 to probe. You don't have to do that, Steve, I think. It really depends on your start. The trick is, I know what you mean. The trick is, if you check my, that's the wrong thing. If you check my start or my machine G code here, in the machine G code, you need to do this. You need to say M90 as 0 and M109 as 0. And then the slicer says like, oh, you put the temperature. Great. So it doesn't inject these 2 statements here. And then basically you just pass your extruder temp to that first layer temperature here. And the bed temp. This is one command. This is not like a new line. Yeah, here we go. And then basically you can do it in your start print G code. And then the slicer doesn't set temperature and the printer doesn't wait for it. So basically with these 2 commands, you are in full control in the print start G code. And then basically you can do heat to 170, do your probing, whatever, and then you heat it. So it saves a bit of time because you don't have to wait for the cooling, which is actually quite annoying, I think. So yeah, that's the little trick there, is to just set it to 0, basically. I'm not quite sure why slices do that. To just assume that you really want to set it there. Okay. That will not work. Okay. I didn't squeeze it on enough. That was like quite loose. I do that as well, but when you now mesh, the bed needs to be hot enough to clean the filament, or maybe clean the nozzle at the end of every bed. Well, the sequence now is basically I heat the bed to the final temperature. On larger printers, I think you should also add like a wait for a certain time that the... Wait, let me quickly focus on this. You should add a wait for a certain time that the bed really like evenly has the temperature, not the section where the probe has the temperature, but like the entire bed has the temperature. It takes like a bit longer. And in the meantime, and in parallel, you can basically also heat the tool head to like 170, for example. I mean, if you want to make it nice, I guess, because for PLA 170 might already cause some oozing. You can make it like dynamic based on the print temperature, maybe like print temperature minus 60 or something. I don't know. Maybe there's some smart way to determine this. And then you do your nozzle wipe. Like you don't wipe at the final print temp. At least this is my first nozzle wipe, so take it with a grain of salt with what I'm saying. But this is what I understand from what people did. Okay, that's all crimped. We need one with two. And there we need this, I noted on this side. So this goes here, and this is our servo pin. I really hope that this is fine because it's the pin goes via like a MOSFET, but yeah, I think it should be fine. And then here we just grab ground and ground and 5 volt. And quickly peek in here. So the ground is in the center. And 5 volt is on the bottom. You know, now that I'm thinking about that, this cable here is the Z end stop. We don't use the Z end stop anymore. We could have removed the Z end stop here and just had all 3 cables on this pin because it has all the things we need. Oh yeah, well, cable is cut. Think twice, cut once, or something like that. Because yeah, like these end stop pins have exactly what we need. Like the missing pin here now on this connector is just like the 5 volt. It's just the IO pin. It's exactly what we need. So we could have like all 3 on one connector. I'm looking for that. Here. For that. Yeah. I'm a bit annoyed now by that. Oh. Okay, but that's basically it from a hardware setup. So now we just have to figure out again how to servo, which I surely forgot. I'm very optimistic and I'm putting it away. Let's see. So it's booting up. Let's give it a hot second. And then we can just check how to control the servo. And then we can just like play around with the servo. First get the servo working. And then we have to update the start sequence. Let me also put this back. That's also on my to-do list is to redo the Nevermore here. I'm just putting it like here in the center position, then we hopefully don't get any accidents. Okay, we have red light. Red light means it's ready. Then let's do some config. So Clipper servo control. So let's just copy the whole thing here. Oh, there's actually a very handy copy icon. Um, at some point, we also need to clean up the config of this machine. Like it's horrible. Let's just poop more stuff into here for now, but on the list. Maximum servo angle is 180, so that depends on the servo type you have. The one I have is 180, I think. Well, we'll figure out. Let's just leave all the things at the standard. I do miss the pin, so we need to set a pin, which is now the fan 1, technically. So it's the IO17. So it's GPIO17. So this is our server, and this is all the configuration we need to do for now. I feel like we just updated all the things here, and like everything's already like outdated again. Yes, then does it say set servo G-code command? So let's quickly look at this. Set servo. So how do we name that now? I don't think we gave it a name, right? Oh, servo my servo. Let's just call this brush, servo brush. So the servo is brush, and the angle, let's just set it to 90 for now. And for width, 1 second. Oops, angle. That didn't do anything, that's good. It doesn't complain, I guess. Uh-oh. I have a bad feeling. The servo position to the given angle in degrees or pulse width? Oh, I think we should not set the width. That still doesn't do anything. Let's troubleshoot. Let me get this out here again. Let's troubleshoot. So the first step would be to check for power. Will it matter you're not using caps? No, it shouldn't. What do you mean by caps? You mean like caps, like in terms of uppercase letters? Shouldn't. I mean, like if I mistype here the value, it complains. So I think that's fine. So my first check would be like, do we have actually 5 volt? And I'm very certain we have it because we have the ground, the brown pin here, and red, and this is okay. It's ground 5 volt. So looks good. You see the red LED here? So this means also that there's, because it's a fan port technically, like we see now there's action happening. So if I set the the width to 0, this will disable that. So still on. I don't like that. Let's do the following. Let's move the yellow cable over to this. Maybe because it's a fan port, there's a MOSFET in between. Maybe that does some weird stuff. Let's move that one over to that connector here. Not case sensitive from the console. What I've seen. No, it's definitely not. It's definitely not. Let's give this 3, 2, 1, power off. Okay, let's quickly allocate this. Also quickly, if we check the pinout. So yeah, the first one should be fine. Oh, come on. Yep, here we go. Now this will be fun. Let's try to get this out here. Oh, yeah. 90% out. Come on. Here we go. Now just put this in the first one. Yeah, that also still holds, so it's good. And then we are at GPIO 0. Let's see what that does. Oh yeah, we also want to change that switch here. Let's see how long the the brush takes. I don't think I have a good way of measuring the voltage here. I could maybe poke in from the back here basically to measure. I'm fairly certain it's 5 volt. Like I don't see how this can be anything else. But there's also no LED on that servo, right? They don't have any status indication or something. Because one servo was already like physically broken. Like my trust is a bit bit low in these servos. Maybe the diag jumper stops positive or negative going to the X. That could be, Steve. I don't think it should. It could be. Let's see. We will, let's quickly see what it does now. We need to change the config quickly. I will change that from GPIO 17. Where is it now? To GPIO 0. We can also maybe take a quick peek at the Poorman CoreXY, how we configured it there. Maybe that's a good one. Let me quickly turn on the Poorman, which by the way is not that. Like I am still working on that. Not actively at the moment because I'm a bit short on time, but it's actually printing quite well. It's like not perfect yet, but we're definitely getting there. I did some tweaking around the linear bearings, and that helped a lot with all the print quality issues. I still have to do some more testing, but it's definitely definitely getting there. Um, this will take a second. It's a pi 0, so let's just save this and see what this does for now. Error. Oh, GPIO. Yeah, we also use it for the LEDs at the moment. Which are non-functional. So let's just put that to 17, which is the fan port we just used. So, and now if I set this to angle 90, aha! It did something. But it doesn't, oh. This is not something servers should do. Okay, so if I set it to 120, now it works. So our target here is 120. And then the bottom position, I guess, let's try 80. Um, Okay. I've never seen that in my life with a servo. This is not how that should work. Okay. I mean, like from the mechanics, this looks fine. Like it feels okay. It has quite some backlash, but it's I think quite normal for these cheap servos. But anyone in the chats seen that before? Yeah, but also like it also went down here like this. And also like when I put it to 60, right? I mean, if I can put it to 50, let's Google. I've never seen something like that. Servo oscillation. MGN 90. Yeah, this is something somewhat what we see, right? Mm, might be some setting. More or less power. Like that's the thing, right? With servo, you don't give power. You basically they only have like 5 volt in ground, and they have the control pin. And for the control pin, you just give it like a PWM frequency, and the frequency basically determines the angle. That's all you can do. This is a really simple device. Let's quickly check the 4-man Corks Y, because there we also have that configured. Mm, Pro servo. There should be servo somewhere. Probe servo. It's not here. Um, Probe servo. Here it is. Um, let's just copy these values because it's technically the same servo, and see if that helps us here. Let's just kill all the default here. Maybe the pulse width thingy, or like the frequency, does something here. That kind of worked. But now it doesn't do anything anymore. Oh, I think this thing is just like defective. Honestly. Oh yeah, look at this. Oh, it's fine. It's just like overcompensating. That's not really how it's supposed to work. I think there's the issue with like the measuring of the angle, and then it just overcompensates. Um, New servo. New servo. That means we need crimping again. Uh, New servo. I'm changing the angle, but like the problem is not the software. Just look at this, right? Like I'm not doing anything. It's just like the servo, you know, like it has the how it works is basically there's a potentiometer, and that measures the angle, and then basically the servo tries to hold that. And basically, if I do this, the resistance of the potentiometer changes, and I think it's just like not compensating properly. So yeah, it's just broken. I have 3 more. Let's do something really smart. See it as a feature. Yeah, it's a free oscillation tool. It's like a multi-tool, you know, like oscillating multi-tools. It's exactly like that. We'll get extra clean. Yeah. Let's do something smart. Let me quickly shut it down. Let's just plug it in as is in the end stop, set end stop. Then we can quickly test if the servo works as expected, and then we can do it again. Man, but that means we have another chance on making the cable better. So I'll just unplug this one here. I'll do my best to unplug this one. And I will unplug that Z end stop here, which is no longer used because we used the probe for Z end stop. And then we can use this, but we quickly have to change the pins. So the ground and 5-volt need to be swapped. Oh no, we lost the corner panel clip. Ah, come on. Number 1. Number 2. Okay. And then we should be able to also, like, we added so much stuff to this machine, I have no clue what is. This one is a label, end stop. It also would be interesting to see, oh, this one goes to the filament sensor, okay? And these are the LEDs, okay. Let's try to wiggle this in here. And the cable length is actually quite good for this, so we can technically just route it through here, down there, and it should be perfect. Okay, just so that we can see what we're doing. And last double check. Ground center 5-volt, bottom signal top, and fire. So we quickly have to change the pin to IO25, which is unused at the moment, and then we should be able to control the servo if it works. Looking back at the stream, it seems you were changing width in the console and not angle. I was, if you set the width to 0, it will turn off the servo. That's the only thing I did with width, I think. At least the only thing I was like like actively doing or like was supposed to do. If you set the width to 0, you turn off the servo. If you don't set width to 0, basically we'll just like try actively keeping the angle. Let me see. GPIO, what did we now say? 17? No, 25. 25. GPIO 25. Save and restart. Should not be used. Perfect. We have a servo. Let's set this to 90. Nope. It should definitely be fine. Not doing anything. Again, like the... Oh, it was not doing anything when we used the fan port. Oh, ballistic tech. You're 1000% right. I'm setting the width right now. But it doesn't do any difference. Like width and angle don't do the same. It's just like width is encoded from 0 to 255, if I recall correctly. Mm, here. Width is position in seconds. I'm not quite sure what the value is. But basically, like, it just controls the PWM signal. So basically, the PWM is like from 0 to 255, basically. And each of these steps basically represents an angle. So basically, all Clipper does is if you set an angle, it takes the max angle you gave it, and it calculates basically that pulse width. But also, this one is not doing anything. Let's quickly try another one. Like my trust in these is really low by now. 5, 4, 3, 2, 1. Far off. Oh, I put it back. Oh, we have to change the pinout again. Let's see if this also doesn't do anything. I would try to use a different I/O pin again. But I wouldn't know what would be wrong with using this pin because yeah, technically it's a Z end stop, but it's not acting as a Z end stop at the moment because we don't use it. And there's no diag pin set here. And we could also do the following. Just to make sure that like it's not a hardware problem, we can use the actual servo port here. That is, yeah, exactly servo. So the 5-volt, yeah. Oh yeah, then we can actually plug it in as is. Just to make sure that like it's not a hardware issue. So let's quickly turn it on. Let's change the pin here. And now that I'm starting to change pin, let me quickly download the config backup because otherwise I might mess stuff up. And then let's just plug it in straight into the servo port. Then the port is exactly intended for doing this. So if it's then not working, it's definitely the servo itself. Let's see. So we are up here. Are we? Initializing. Let me quickly download the whole thing. And then in printer config, we need to remove the, let's quickly check for the pin. So this is IO29. So somewhere we use GPIO29. here, and then let's just put this to 25, which is that end stop we just used, and then for the servo we use 29. Save and restart. Okay, I quickly want to shut down. I don't like plugging in stuff while it's running. And then the disorientation, so the yellow cable to the right. Let's see what this does. It's like one bad servo is like kind of like okay, but like now we have two already. Maybe you shouldn't buy the cheap AliExpress ones, but I'm actually not quite sure where else you would like buy servos, because like everyone sells the same stuff. Like no matter where you buy it, it's coming from the same factory. Okay. And the servo should be up and running. It works. Okay, it also like holds the position, and if I manipulate it, like it doesn't do anything bad. So that seems to work. Oh yeah, see in ballistic tech, if I now set the width to 0, now it's just like disengaged. Like now I can turn it manually again. So this seems good. So now we know this one is a good one. Let's do it as next step. We try it on that that port we have here. And then if we know this works, then everything should be fine. So if it doesn't work here on this port, we know it's like a hardware issue with that specific port. And then to use it on this port, we quickly have to swap the two pins. I guess you get what you pay for. Yeah, I fear so. Because the first two, like the first one is clearly a hardware defect, right? Like it's locking up, so that's clearly a hardware defect. The second one, where we have this oscillation issue, I guarantee you this is not a config issue. That's like I guarantee you this is not a config issue. Okay. Also, just to double check, let's look at the pinout again. So we have the ground in the center, the I/O pin on top, and 5 volt on the bottom. Oh, I'm fairly certain it's fine, but now it will be controlled as a LED. So let's quickly do the extra step and first change the config, then plug it in. The thing is, like, if it's controlled like LD, I'm not quite sure what it will do. Most likely nothing too good. Any hobby model shop will sell the servos for radio controller toys. Yeah, but like the things, like if I now go to like any hobby shop, right, and I buy MG90S servos, It will be the same one, right? I don't think there's like different quality levels of MG90S servos. It's just like the same factories in China pooping out the same things, right? That's what I mean. Like, no matter where I buy them, like I would expect that they're like the same shit quality. I actually like side story there. Like, we have like some electronic shops here where you can order, and I have like next day delivery, which is really cool. And a while ago, I was ordering fans, like 24-volt fans for Toolhead. I don't know I don't know which fan exactly it was. Um, and I first ordered at AliExpress, and it was like horrible fans, like positively horrible fans. It was like 50-15 24-volt. I got the cheap ones because it was just like for trying out. It was horrible. Then I ordered at the electronics shop, and I got the same horrible fan. I don't have them here, but it's like it has like this blue yellow label. And it was the exact same horrible fan. The only difference is on AliExpress I paid €2 and I got the horrible fan, and on the electronics shop webpage I paid €6 and got the same horrible fan. Next day delivery. So I don't know, like I'm really like disillusioned when it comes to like stuff like that, because they all just order the same AliExpress stuff. So yeah. So I'm really curious if there's like a, like brand MG90S servos you can buy where you have like quality control and they're good. So this one should now work. It worked on the other port. Oh yeah, make sure to sign up for the Discord. We now have a Discord. I'm trying to promote it a bit. You see it, the link is in the description. Amazon have different brands. Maybe find a forum that will tell best brand. I could check. But yeah, the things like they all look exactly the same, right? Like there's the MG9, it's the same label, it's the same color, it's like all the same. So I'm not quite sure if there's like a industry standard where you say like, oh, MG90S always have to be exactly like this visually, but otherwise I would assume they're all from the same factory. But yes, it's a good one. Like most likely people tried out different sellers. Come on, here you go. Moment of truth. No work. Okay, so this part does not work. Okay, we learned that. So we have a known good servo. It doesn't work here. Okay, check. Then let's do the next step. And I wonder why though. Like it's a bit odd. So pinout wise, let's try the IO0 again, like where we also plugged in the current one. So I'll already change config now, so we don't have to do that later. Um, so we put this on IO0. Printer config is saved, and then we can just shut down. Oh, we didn't change the LEDs back, right? Well, let's do like a very quick test here. So I'll just remove the yellow pin. You just split this, and then let's quickly crimp new connector on that. At some point, maybe we should just get like expander board to have like more proper I/O pins that don't have any like side function like that and stuff. But it's just really hard to fit it in here. That's why I prefer to not have any extra boards. Okay, we do have a random loose pin here, but there's no power on there, so I'm not super concerned. Okay, let's just make sure this is kind of like all somewhere here. Then this can go back. We don't really care which one of these. Okay. Can all pins output PWM? I think they should, but not expert. The only thing, but I think Clipper should complain if that would be not the case. I think you can change, at least for fans. I don't see the configuration here. You can change between software PWM and hardware PWM, but I think all pins should be able to output software PWM. No, you can't configure this here. But it's the thing, like I think some pins have like certain limitations, but I'm not quite sure about these limitations. Let's see. We had some movement here. It works. By the way, so how this works is basically if I now apply pressure, the servo realizes that the actual position is off, and then it like uses the motor to move back to the proper position. So when you put a little bit of pressure on it, you feel it like starting to vibrate a bit. And I think this is what goes wrong with this one. Like it doesn't measure the position correctly. So when it goes off a bit, like it fails to correct itself properly, and that like induces oscillation. Which will refit the old board you removed RGB will work and have extra pin outs. Yeah, but it doesn't have a lot of pins. And I don't know where to put it, Steve. That's my problem. Like, you know, like it's kind of full. What would be really cool, like if I would like redo the electronics on this machine, if I would, which I will not. I would go for like a M4P board here or a M5P. I think the M4P would fit perfectly fine. Then you get rid of the Raspberry. You get rid of the main board. And you just have one board with all this stuff on it. And then also you don't need that middle cable channel because like most cables are just gone. So that would be really cool. If I would redo it, that's what I would do. And then you have like way more pins. But technically, yeah, like we could maybe squeeze a board over here. Like if we move the Raspberry bit to the center, we could like wiggle something in there. But yeah. And also like we kind of like connect everything that there is to connect. So I don't think we need need anything more. Um, yeah, cool. This works. We have to recrimp these quickly. The Pfizer catalyst is good in that regard, but doesn't have a ton of extra oil. The catalyst is also specifically for the V0, right? There was one of these like specially made boards. Before we crimp that now, we have to let's install first the servo and then like let's do the cabling. I already have to remove this pin here now. Yeah, doesn't want it. This is not cooperative. Why is this pin not coming out? Okay, now it will come out. Now I damaged the housing here a bit. Let's quickly check if it still plugs in. Yeah, no problem. Okay, cool. Then this and this can go. And then we can redo the front. Which is always fun. I'm not sure if this fits. Is this not the right one? No, it fits. Now it fits. Fun. We were so close. I already this back. Okay, lesson learned. Before you like install the servo, test it. You know, this endeavor we could have like saved a lot of time by just first doing the software in a certain way and then installing it. Yeah, it's for the V0, yeah. It's like I think I've seen it. It's quite a cool board. I have the M4P, Big Tree Tech M4P in the Switchwire. And it also fits in the V0. And it's actually like a really cool board. So that would be kind of like my go-to. So this is the max. So if we now install the brush facing down, we have enough like reach. Okay. Let's snip off that DuPont connector. I'm not super eager to do this again, to be honest. I'm not sure if you already would have passed the break-even point of taking the panels off or not. Okay, that's a good height. We might be around the break-even point now. Okay, I will recrimp the yellow cable that we don't have like a ton of cable here. But maybe it would be also a fun project at some point, just like revisiting and redoing the electronics of this machine, just like, you know, like clean up. So I'm really not sure like what stuff does sometimes. Oh, we also have the button here. I totally forgot that. I didn't use that anymore for some time, but we added the button here at some point. And that's like the other pins here. That's also something maybe we can could remove. Cable. Okay. That's number uno. And then lengthwise here, let's just keep it almost the same. Here we go. At least these cables are relatively easy to crimp, so this doesn't take like too much time. Let's quickly reuse these. Okay, last attempt, then we take a new one. Ground, let's double check before we have to do it again. Ground is center, and the 5-volt is bottom. Nope. Bottom is this side. Okay, let's put this in the cable channel. Yeah, to be honest, like we can also use any of these. Then we can plug this one back in. Not using that at the moment, but who knows. Okay. I'm optimistic and close this up. Let's see. This one was also defective. Not that I'm now mixing up my servos. This one was the one that jitters. So 2 out of 5 are already broken. That's a good quota. Okay. Let's see. Do we have movement? Yes. Not the movement I wanted, but uh-oh. Yeah, but it can move here. Now it's like really hard down. Why doesn't it move where where it's supposed to move? Okay. So this is 180. So it's like this. And 120. So this is 90, seemingly. Um, which is quite weird. Oh, maximum servo angle is 135. That's not correct. Let's say 180. Save and restart. I remember with the poor man corks why we also had some funny stuff going on. So this is 180 now. Let's do the following. Let's just use the width for now. No, okay, doesn't do anything with width. Because like, it can easily move up here. Like this is really easy. Nope. Okay, now it can't move down anymore. What? Oh, no, it's fine. Okay. Oh yeah, we can also reposition the arm. Let's do this. So I move it to 90. Um, so I'm just moving the arm. Okay, let's see now. So now it's 90. Um, that's 40. That's 0. Eh. So if we set 0 here. Ha! That's now 120 degrees, but you know, um, whatever. So this is 120 and this is 0. Perfect. Yay! This took forever. Cool. The only thing is like it's really easy to move the arm. Um, let's leave it like this for now. I think it will be fine. If it makes problems, I would just glue the arm to the gear cautiously. Okay, but this is technically working. So yeah, I think that's why the angle for the Poorman was set to 135 because I figured that like at 135 it's actually like 90 degrees 90 for some reason. Yay! That was quite something. Okay, let's program it. So let's quickly home. Oops. Oh yeah, no. Don't move it while it's home set because then it like picks up some random stuff. The brush just fits behind the bed. Also scrubs the back of the bed also a bit, but yeah, could be worse. Okay, so then the bed needs to move down. That's the first thing, right? So we need to go to maybe like let's see how deep we need to go. 80 is not enough. Yeah, we need to go to 100. So it's basically all the way down almost. And now we should be able to move this without problem. Yeah, perfect. The only thing I will do, I will move this tiny bit down. So now the bed should have a tiny bit more. Okay, so now it just touches because like if you have the servo, if the servo tries to move into something, it will constantly try to push with the motor and it gets really hot and it breaks it quite easy. So like in the end positions, there should be no force on the servo ideally. Just something I noticed right now with you opening and closing the top. I printed another handle used on the sides and attached it to the front of the top. Oh, you mean like here? Like here? Not sure if I need that. I mean, it's nice, I guess. But that usually works quite well. The only thing is you need to open the door, but you can also, of course, not. I'm not sure if I personally need the handle there, to be honest. Okay, so macros. Let's create just a brush nozzle macro. Just a completely new thing. Um, brush nozzle. Here we go. So first thing we need is I have a macro called chohm. So it's like conditional home. It came from the LDO kit. It's actually quite handy. So if the printer is not homed, it will home. Then we go to G90, so absolute coordinate space. And then we move to Z. We said 100. Then that's step one. Um, let me quickly add a second tab here. We can like do two things in parallel. Let's quickly move the printhead to where it needs to be. So let's server pro brush angle 120. And then we can move the printhead where it needs to be. I will give you the perfect perspective here. It's a bit small on the side, but you should still see like what's going on. So that looks quite centered to me. And then the height is now a little bit too low, right? So maybe this needs to be now like 125. Yeah, now it's the brush just went a bit higher. And then on Y, let's move back. Yeah, I think we should like move the servo up like a tiny bit. No, actually should be fine. Let's try it with this. So the front of the brush is, so this is kind of the front position of our brush, just like in the beginning. And this is X6, perfect, and Y70. I like it, nice numbers. So now we go to we move the bed down. All right, let me quickly scooch over here a bit. We move. So now we need to say servo is brush, right? I'll just copy that. So we deploy the servo. And then at the end, we can already say angle 0. And then what we do is we say width 0. And the width 0 basically turns off the servo. So it doesn't actively hold the 0-degree position. And in between, we now need to go to G1 X 6 Y 70. So maybe let's also already position in this move here. Let's already move to this position. And then we deploy the servo. Maybe let's go to 65. So tet in front. And then we need like a loop that we repeat something. Because I kind of want to go through like maybe 5 times. Clipper macro loop. Oh, I think actually we have one here. Podcast. There we go. It's like a stupid thing I made. I was like on a podcast at some point, interviewed, and I wanted the printer to move in the background, so this just loops forever. Now, where did we brush? Here. So we loop, and we say and for, I think. Yeah, and for. So, and now basically what we need to do in between these two is like we need to move back and forth. So this is the front position we had. And relatively slow. So let's just do, I don't know, like F700. I don't know, like let's try this in a second. And then we first go to the back position because we kind of initialized here with the front position. So this would be 6, but then most likely 100, I would assume. Maybe a bit more, maybe 110. So let's quickly test this move. Yeah, this is relatively slow. And also like a bit behind the brush now. So let's just stay inside the brush. So let's do 105 and then maybe 1000. So this is now the move to go back to the front. Yeah, so 65 here. Actually, we exit the brush and 1500. like right now I heard the servo trying to push up, so there was a bit of like force on the brush, so maybe it's good to just exit there. So F 1500, and this maybe like not forever, but maybe like 5 times. And then we store the servo and we are done. So this is basically our brush nozzle macro. So save that. Let's do like a quick firmware restart. Oh, we also should init the servo, I think. Let's do that as well. There is in the printer config, in servo, and here we can set initial angle 0. If we do that, it will now stash. Yeah. So basically, when Clipper starts, it just like stashes that away. So if, for example, like you have a firmware reset or something, and like for example, it fails like while cleaning the nozzle, and it restarts, like it doesn't crash then into the bed and stuff like that. So I think that's good. So if we just say brush nozzle, it should now home because we have the conditional home. Hi there, Jonas. Sorry, I totally missed you. The conditional home, and then it should deploy and brush. Yeah, the brush just touches the bed, which is a bit annoying, but yeah. Okay. It worked, but I think the problem here is we brush, where is it? Here. We set the angle 0 and then immediately set width 0. I think we need to add a G4 S4, I think. That's a 4-second delay. No, 4 is a bit much. Maybe like, let's quickly check. There's S and T or something. G code, wait, it's dual. P. So we just say P500, so it waits half a second for the servo to like stow, and then we turn off the signal. Now, also what we need to do is we need to heat the nozzle. For the probe, let's quickly save that. We have a very handy dandy script. So the probe is here, and we have this like activate G code. I would just pull this out. Yeah, let's create a macro from this. Let's create a macro from this called ensure probe temp. Ensure probe temp. And then we say brush nozzle. This is our new macro we just made. And then basically, when you activate the probe, it will check that the temperature is at 170 degrees. And then it will brush the nozzle, and then it will probe. So macros, brush. Let's just put it here in that same region. So this is G code, macro, and ensure probe temp. I think this is how we called it. I already forgot. And we just paste this entire thing here. Just like to double check, I'll quickly copy this. Save, printer, probe, probe. Ensure probe temp. Yes, I remembered correctly. Here we go. Will the brush crash into the bed if the bed is raised when Clipper restarts? You just got your answer live there. Because we set the initial angle to 0, as soon as Clipper starts, it will make sure the servo is at 0. The only thing that's a bit bad about this is like now the servo is active. Like it tries to keep the 0 position. So I think we will change this. Let's actually change this right now. You can have these delayed G-code. Here we go. No. Here we go. These delayed G-code. And here we can basically, let's create a new macro and say like stow brush. So basically when Clipper starts, you just run this macro. And then we can here brush nozzle. Here it is. Let's just create a new macro. G code stow brush G code. And then we just copy these lines here. So basically, instead of like activating the servo and having it actively at 0, we just like set it to 0, and then with equals 0, we turn it off. It's a bit nicer. Let's put this here. And then in the basically when Clipper starts, it will stow it. And just to do the to ensure that's correct, initial servo. We can remove this initial angle from here. Okay, perfect. So if we, just to test, if we now set that servo to 120, so now it's deployed, and now we do firmware restart. It should, yeah, you saw it, like it moved it back. But now it's also inactive, so I can move it by hand, so it doesn't like burn the servo as quickly. Cool. So basically that hopefully answers your question. But what if the bed was up? Well, if the bed was up, the probe hopefully was deployed, was like stowed already, right? Like Clipper will now always move it to this position. So if you mean like if the bed was here, but then the probe should technically always be deployed. Unless we manually did that, which would be quite stupid. I mean, what we could do to address your concern is in the homing override. Home. The homing override in this printer is really weird. We can hear. Oh, I accidentally pressed escape. Homing override. What we can do here is we can also say at the beginning, stow probe. And then if the bed would be up and moves down, the probe would be stowed. Not probe, brush. I think this should be fine, right? Yeah, should be fine. So let's try our brushing sequence. So now we also added, yeah, he kind of like hits it a bit, which is fine. Yeah. Let's try our macro again. So it should home, it should heat the nozzle. Now the question. Actually, we made a mistake. Not sure, Ballistic Tech, if you meant that. Because we now added our brush nozzle here, but the probe, let me quickly show that. The probe is used for the Z homing. So that is now a problem. Because now basically I think this will create a loop in a certain sense, because like the brush nozzle will home, the home will deploy the probe, and the probe will brush and it will home. So it's like an endless loop. I think if we would really want to do this like this, we would need to use the Z end stop. on the bottom, which we could technically. But for now, let's just remove this here and move this to the start G code. Macros start G code. Start, print start. Because here we have chom and then we have bad mesh calibrate. So we just, before we bad mesh, we brush the nozzle. I think that's nicer. Technically, we have the end stop, right? Technically, we have the end stop. Let's do the end stop. We have the end stop anyways. Okay, last time I changed my mind. So we go to printer config, the probe. So the end stop pin, we go back to the GPIO 25. So we use the normal end stop, and the end stop position end stop is now 121 or something, I think it was. We need to quickly calibrate that. And then on the probe, wherever the probe is, here, we actually add the brush nozzle, because this is now not used for homing anymore. Position end stop and section must be between position min and position max. Okay, check. So the stepper Z, the end stop position is 120 in this case then. Save and restart. Okay. Let's quickly home and see if that works. So it should home to the bottom. Which it does. Perfect. The only thing is now, like, when we really like home and then brush a nozzle, like it goes up and down. So maybe we should like change the homing override to not move the bed up. Let's quickly test the brush nozzle. And I think we can move down quicker. Nope. Oh, you don't see it, but it's like way up now. How did that happen? Did we? No, that is fixed. Funny. Let's quickly. Why is this now lower? I think the arm moved a bit on the wheel. I think we need to glue that. Like, this is not really holding in place. For now, let's quickly change the angle. Let's also make a macro deploy brush, just like to keep it a bit clean. Deploy brush, and then the angle is 135, and we remove that thing here. Deploy brush. Okay. So if we now hit save and restart Ballistic Tech, I think you're correct. It would now hit the bed if it would do that. Let's do the following. Let's not do this after the startup. So Ballistic Tech, you were 100% right. Let's do it as part of the homing. So in the, we home, and then here we have the Z20. So basically before we do this, we say deploy stow brush. So here we know we are on the bottom. And then here I would just actually remove this and just go to 111. And then the other thing we wanted to do, right, is like we wanted to speed up that initial movement. This initial movement here, I think we can do this to 10,000. It's just like the Z will limit. Now the brush should stay up. And now we home. Oh, but now it did it before it moved Z, which worked out in this case. But we still had stow brush here. So if we do this again, so we say deploy brush. And now we say firmware restart. It should stay up until we home Z. So it's still up. Now the bed is homed. Now it deploys. So Ballistic Tech, you had a very valid case. Thank you. Perfect. Let's try the wipe nozzle. Wipe. Or brush nozzle, right? Brush nozzle. No, it does it. But didn't put the temperature up. So we are missing the brush nozzle. We are missing ensure probe temp. Although I think ensure probe temp only does something when the temperature is hotter. So this will not work. Let's print something. Let's just try it. Let's just try it. I think it should work now. At primitive or at handy model, let's do like handy dandy Voron cube. I think we can also increase the speeds quite a bit. Let's just use this as a quality test. So we now have 10,000 as a recommended acceleration. So let's just go for 10,000. The outer walls I leave down. And travel, we can also at least put it to 10,000. So this should be fine. And slice. We send it. There's one essential, very critical part we need to do though, which is we need filament. And this is now sliced for the Foam Futura filament, but it's black. I don't like black for the stream. Let's go with green. A slightly different filament profile. You know what, actually? Let's just quickly emergency stop that bad boy. And I quickly changed the filament here to no fill. Slice. Print. Oh, but we are now in the, wait, firmware restart. Print. Upload and print. My display wants to go to standby. Oh, we don't have a spool holder. Hey. We didn't put the electronics panel back. Easy fix, luckily. Let's put a Nevermore back. Let's put a door. I kind of like have to assemble half the printer still. There we go. I have a rear hinge mod on all 3 of my Zero now. What is a rear hinge mod? I've never heard of that. Oh, yeah. So that goes into the direction of my panels, right? Like I kind of want to redo the panels. The panel clips to just like easier take it on and off. But I think this would be maybe like a nice step in between. It's a very good suggestion. I'll pick it up. I will do that. That will already help a lot. Oh, it comes with its own spool holder as well. Nice. Oh, but this spool holder doesn't fold in. So now I need like a rear hinge mod with a foldable spool holder. Although technically, like in my old apartment, like the printer was directly against the wall. That's not the case anymore. So I don't think I need a foldable spool holder anymore. I'll put it on a list. And I also will order like a new brush because this one is like quite done. But all the new brushes I ordered, I didn't pay attention, and they're like this, so they're like completely like curved, so it doesn't really like suit the needs we have here. Nice brushes, but curved. The LDO spool holder works with it. Oh yeah, I have a different one. I have this one where you can put it in and out. Yeah, because like it was against the wall, technically in the spot it was like sitting. I still want to have the spool holder, but like not sticking out. Let's see how far the heating is. Yeah, so basically we now heat the nozzle to 165 degrees, which is perfect. And I just wonder if we can like 165 it won't flow, I guess. No, it doesn't. It's not gonna ooze on us. With 165, it's not hot enough. Oh, it did. Do you see it? There's some black filament hanging out. I'm not sure if you can. There you see it. So this should be brushed away. Why not take a comp to straighten the bristles? I don't have a comp. That's something, it's like one of these things like I should get. Maybe this is now like the thing to like get me over the edge. No, but what it is just like push them back in and it already like looks a lot better. But I think a comp is a nice idea. I'll order a comp because I should have one anyways. Print one, yeah. I mean tech. Yeah, you could print that. Right? Yes, people designed it. I will print a comp. Of course you can print it. I was like, just like, like because the comb hairs, I don't know how to call it. They're quite thin, so I was like, can you print it? But yeah, of course, like if you just put it flat on the bed, should be like quite good actually. Use your heat gun and straighten the brushes. Also possible, man. So many ideas. And I just ordered new ones. Now I feel bad. Let's see, what's the heating doing? That's the one thing I don't like about filament. Like I put the bed to 110 and it takes like quite a while to heat up. Like especially like the last section. Like the hotter it gets, the longer it takes to like get more degrees. Let's see. I think I also never printed with. I did have 10,000 acceleration before on the machine, but I think I overdid it back then. But now, like new rail, uh, CNC, XY joint, CNC, X carriage, should rock. That should be good. I might remove the sticker from the servo. Like I'm a bit bothered by the pink bit there. That's a quick change. I use a silicone brush from Teddy with shortened bristles. Yeah, I've also seen quite a bit of different like approaches there. I mean, technically I can use anything because I can adjust the height quite easily. I also saw that you can like the Bamboo Lab silicone brushes. You can also get them aftermarket. Um, I mean, they seem to work quite well. I also saw. I mean, if you look for nozzle brush or on zero on printables, um, you find quite a lot of different designs. Like this one. This one was actually quite interesting because it has like an end stop pin as well. So you can have the like the automatic Z calibration. Well, yeah, it says experimental, so maybe not. Um, yeah, this one's also different design. Oh yeah, see, this one uses a silicone one. Well, I actually didn't see this one. This one actually is a nicer design because it's like way more compact than this one. Ha! Maybe I'll change it. But like we did all the hard work. Like now, if we would change the arm, it's like really easy. Oh yeah, and they use the A1 silicone nozzle brush, so it's really easy to swap. All the work done for nothing. Nah, I mean, really, like if you would swap to one of these systems, all you need to do is like have a new mount and the new arm. That's really it. And then you need to change the. You don't even have to change the macros so much. You just have to change the wiping positions. That's it. Silicon one would also remove the bed touching, the brass one. Yes. RaveCube, yeah, you're right. I mean, the touching is not really bad, to be honest. Like, it's really like it's minimal. Like two bristles basically touch it. But yeah, this one actually looks nicer. I might change that. I just have to like order this silicone brush, but it can't be expensive. I mainly use silicone because I use clicky, and with the 24 volt and metal brush, you get some fun fireworks. Oh shit, yeah. So here's one thing I noticed. When I manually brushed it, sometimes the LEDs turned off because I shortened accidentally the LEDs with the press. So that's actually a very valid reason, Jonas, for going with silicone there. Oh, it's happening. It's happening error. Timer to close. What? Odd. Aren't there also brushes with nylon bristles? Yeah, also exists for sure. Oh, let me quickly see. The only thing like you need to pay attention to like it doesn't melt at 165 degrees. Oh, come on. Let me quickly do a... Oh, now it did shut down. Yeah. Let's restart quickly. No clue what that was now. Like, I haven't had it in quite some time. Like, it happened 3 weeks before something. And basically it means that there's like the CPU has too much stuff to do. I actually wanted to swap out the Pi in here. Like I still have a different Pi. The Pi here has only 1 GB of RAM, which is tight. And I think that's causing this issue sometimes. I still have like one with like 2 GB flying around, so maybe I just swap them. I saw a cleaner that used a piece of PTFE tube on a printed spring. Yeah, I also saw this one, but not for the Zero. But I mean, you can always adopt it, right? I still sometimes use the metal one for deep clean, and I had some fun sparks already. That's the thing, like, since I now brush the nozzle regularly with the brass one, like, it's very nice and clean. I have the old nozzle here that I used before I swapped to the high flow. It's like super dirty. It's like completely baked with filament, but like um, the high flow one now I use, it's really, really nice. Okay, let's give this a second. Not sure what we now did. It was very close to greatness. Let me quickly check the logs. No clue. What's up now? Um, unable to transmit. Okay. Fun times. Um, do we have a can? We have a can 0. Okay, so this is there. Let's check if we see. Okay, so we don't see the EBB anymore. I have no clue what just happened. No, Rainkeeper is not a config issue. It is not a config issue. Let me quickly pull out the filament that we don't have to deal with. So it can't connect to the canvas tool port anymore. All of a sudden. Well, I'm not quite sure why it worked the entire time, and now it's suddenly... I mean, we didn't change anything here. This is all fine, like it has power. Let's quickly do like a hard reset and like wait for a second for all the power to drain. Can you use thin glass instead of acrylic? You mean for panels? I guess you can. It's just like a bit breakable. So I wouldn't do it, to be honest. Like I would be afraid of breaking the glass. The bed was just at 110 degrees. Yep, no, okay. I have no clue what this was now. It should connect in a second because it did the LED thingy. Here we go. I have no clue what this was now. Let's try again. There's another interesting design on printables. Let me quickly copy this. With the animation. I'm sold. Oh, the other one also had animation. Oh yeah, I've seen that. I've seen that one. This one is more similar to the one with the PTFE tube and spring, right? Because it has a similar like working mechanism. Um, I don't know. Like to be honest, I think you kind of have to try out different ones and see what works well for you. Because here's like what like we have this now set up, but like changing the macros is like no work at all, unless the printer does weird stuff. Um, there's a video in the details even. Oh, can I? Oh yeah. Oh, only once? Oh, oh yeah, there we go. But he goes quite hard against the servo. And no prime line. That's also nice. Interesting. I'll put that also on the list to check out. But yeah, I think you can just like try different versions of that very really easy. Like once you have it in place, it's just like mounting the servo differently and changing like the macro tiny bit. Uh, we'll have to use shatterproof glass. Yeah. So if you want to use glass, then shatterproof, I guess. And then I don't know. I feel like it would be a lot more expensive than acrylic. The only benefit is like it doesn't scratch as easily. Let's see. 104 degrees, so we're almost there. Let's hope the second attempt works better. Oh, and filament. Let's load some filament. Does a better mainboard result in better performance in Clipper? For example, Raspberry Pi 5 versus 0 to W. I'm using a HP T6. It doesn't really like to be like it depends, right? Like depends what you want to do. The 2.0 will be fine for Clipper. Important is that's a 2, not the 1.0, but the 2.0. That will be fine for Clipper. If you plan on adding like a lot of additional stuff onto it, then the 2.0 might go down. You also have seen it now here. This is like a Pi 4 with 1 GB, and you kind of see what you don't see what it's doing. Can I? Yeah. You see here this is the CPU load of the Pi 4. So you see the CPU doesn't do anything really. The Pi 4 is more than capable than for running Clipper. I jinxed it by saying that. Okay, something is wrong with that EBB. It's the same failure again. Timer too close. The question now is if it's a communication problem. Because like, yeah, it says like it's a performance issue, as we discussed it, but it's not a performance issue. Like looking at the usage of resources, it's not. Okay, at least now it started right away. I have no clue. This is really weird. I never had that before. Yeah, I would agree, Steve, that it's like a signal wire issue, but we didn't change it, right? Like we didn't touch it at all. 3 times the charm. Let's quickly try it. If it works, it works. Otherwise, yeah, I would like redo the cable on the backside end. Backside, in the back the cable. Maybe it like slipped a bit or something. But yeah, it seems to be like a communication issue, like not a It's just weird. Like we used, like we know all the macros and everything was all fine, right? So like temperature. Yeah, also temperature. Like the EBB has 39 degrees, so that's also like not a problem at all. I assume it's a communication issue on the CAN bus. Man, it's like one thing fixed, it's like another thing pops up immediately. It's cool. I like it. 109. But also it's immediately, right? You shouldn't miss the magic moment. Oh, yeah, well, that's something we can optimize, right? Like we moved the bed up, then we moved the bed down, and now we nozzle wiped. I didn't break it off. You can see now it's like there's a G-code failure is one thing. Uh, you can't really see it because it's black and it's not focusing, but it's now like stuck here on the side of it. So it didn't quite wipe it off. Um, Tool that move during probe activate G-code script. So seemingly that's not allowed. Okay. I'll keep the bed temp at 110. Um, Printer config. So the activate. So we are not allowed to use brush nozzle in the activate G-code script seemingly. So we remove that here and we just move it over to the macros start print start, and then we just say brush nozzle before bed mesh calibrates. Let's try again. Yeah, EBB temp is like 39 degrees, so that should be fine. Okay, we'll need to optimize. Oh, we didn't restart, right? My bad. we didn't restart. That would have helped a lot to like actually apply the config changes. But now you can observe it again, like beautifully brushing the nozzle. Firmware restart. Let's try again. Yeah, the EBB temp like it's really fine. Like I've observed EBB temp being like 65 degrees before, usually during printing or like longer printing. So it's definitely fine. And also now it's fine again. So it's like most likely issue with the cable indeed. No clue. Temp needs to be more. Okay, yeah. So you would go a bit more aggressive, Steve. Let's just do that. I mean, now it's fine because it's clean anyways. It's just something I need to try out a couple of times. See what works, what not. So let's say 200 degrees here. And then you would go faster, you said. So let's just do like 2000. 2500. It's like a proper brushing. Yep. Are we printing still? Yeah, we're printing still. Yeah, let's do just the firmware restart quickly and then print again. Okay. We barely lost half a degree on the bat. I'm using BTP Octopus Pro 1.1 and a HP with an AMD. And yeah, if you have like an x86 CPU, like you're way over any performance requirements of Clipper. Anyways, there's no problem. Just put Linux on that thing and like it works fine. And the Octopus, any mainboard will do. It's also like if you are not planning on like breaking like speed records, like any mainboard will suffice basically. See if we get the bad temp back up. For some reason the bed doesn't heat properly right now. Like it's taking really, really long. 108, 184, 185. That's taking its sweet time. I'm considering like just because I'm finding myself often waiting for the last like 1-2 degrees when starting a print. Like I'm considering just like moving the temperature down to 105 or something for the bed for a filament. I don't think it makes a huge difference. That's really like the last degrees is like it's really slow. Here we go. What now? Oh, now it's heating. I was like, why it doesn't do anything? Now it's heating. The only thing is I should like synchronize these temperatures because I've already set like a cooler temperature when the bed is heating. They should just be the same, that we don't have like additional wait time. Set attempts to. Oh, yeah, it's actually a good idea, Steve. But now we have a perfectly brushed nozzle. But yeah, it's a good idea to just cool the nozzle while you brush. It's a good idea. I'll definitely do that. But let's just see if we get like a print going. And now it's dropping back to 170, but it's reasonably fast. Also need to double check what the max temp is like you can touch the PI sheet with. If 170 is really the max temp, or if there's like maybe a little bit of wiggle room and you can maybe do it with like 200. The thing is, just like with the V0, I'm kind of like, I try to keep the print preparation phase short. So if I now add like probing and brushing and waiting, it takes relatively long to start a print. But the probing is actually quite cool. Like I even with the bed being very small, I do find that the springs are like changing relatively quickly for me. Maybe something I need to look into. 170 to 180. Yeah, so I'm kind of like in range there. I'm at 170. Taking, I guess if I could go to 180. Okay, it did not properly probe there. Let's try one more time. That's the issue I sometimes have with the PC probe. Like I still get like false positives. Sometimes when it probes, and then it cancels the print, which is like really annoying. Because Clipper just ends the print and then like that's it. It just doesn't do anything. I'm not sure if there's a cancel print macro I can override to like notify myself in some way. But the print is just sitting in there, and like you think like, oh, it's waiting for the bad temperature or something. Yeah. Did it do another Z home after brushing the nozzle? No, it did not. I'm so glad for ChatGPT at this point. I tell it what is happening, and it will write me the code. Yeah, ChatGPT is pretty good by now. As a software developer, I'm basically like out of a job in at least the latest in 3 years, I think. Are you using any UPS for a printer? No, I don't. But I also depends where you are, right? Like I don't think I ever experienced a power outage in 10 years or something. So it's not really a thing here. But I guess if you're like in a country where like the power is more unstable, might be worth it, especially if you do really long prints. Um, so if you know like you have like a 5-day print and then day 4.5, like the okay, I don't think usually if I have this, what helps is exactly what I'm doing here now, like opening the head and like releasing tension on the filament. This might be because we changed the rail. That now the sensitivity of the PC probe is incorrect. Let's try one more time. I hate writing these macros and code in general. Well, I do it for a living, actually. No, I really enjoy it. It's quite fun. There might be value in the code that gets mixed up in something. What do you mean for what? For the issue we now have? No, it's the PC probe is incorrectly configured. Grok3 is also very good for troubleshooting. Yeah, it's like I prefer the ChatGPT responses in some way. But yeah, it's also the Claude Sonnet or however it's called Sonnet. Like yeah, they're all pretty good by now. Okay. So here's what I would do. I didn't want to stream like all too long today, so let's give this one more shot. So the issue basically is quite clear. It's the configuration of the PZ probe. So there's this button on the bottom of the PZ probe where you can like change the sensitivity. At the moment, we are on the, let's quick check the docs. Yeah, it doesn't do it. It's not doing it. It's too sensitive. So the PZ probe documentation. Okay, that's. I would be really disappointed if we don't have a print. Configuration. Commands. Presets. That's what I wanted. So at the moment, the center LD is on. So we are in preset 2 here. Set LD on? Really hard to see sometimes. Yeah, we are on the center LD of the PZ board. So we are in preset 2. And preset 2 is this here. Is this correct? Yeah, it must be correct. We are on preset 2. Interesting. So it's the threshold 15 and no active filter. No, it can't be. We're not in preset 2. We're definitely in preset 2. Okay, interesting. Let's try, because like you see the threshold here, basically it's how sensitive it is. Lower is more sensitive. But there's one with a filter. I wonder why. Let's just quickly give like preset 5 a shot. Preset 5 is on, off, on. So let's just move the bat to the bottom. And then I try to hit the button. So the button is a bit hidden. Yep, now we are in the preset with on, off, on. So let's just try this again with homing Z. Oh, we don't use the probe anymore to home Z. Never mind me. Probe probe accuracy. Here, repeated probe check. Probe accuracy, yeah. Let's try this. This is way too hard. Way too hard. Let's try then the preset 4, which is, from my perspective, off, 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 on. Off, off, on. Yeah, it was kind of to be expected that like the change in the rail changes this stuff. Off, off, on. Could you compare it? So the one next to the mortar center is on. Yeah. Okay. Let's try again. Oh, poor camera. Um, okay, that looks good. So this is now quite okay. Let's do the following. Let's put the fan on because we know that this causes issues. Oh, now it's waiting for it to heat to 170. But yeah, so basically the fan introduces vibrations and the PC Pro picks up the vibrations. That's a bit of an issue. Let's see. I fear now it's too insensitive. So it's just like trial and error. A bit annoying. Oops. What? No trigger of the Pro? Yeah, now it most likely doesn't pick up the touch at all. It seems to work fine. Yeah, that's a trial and error. Like also like after the last stream where we installed the PC Pro, like I just had to like sit down and like try a bit and like find the right preset. Okay, now it seems fine. Okay, let's do one more shot at this print. One more shot. Now we are cooling down to 170. Yeah, so I think Steve, like you're definitely right. Like this cooling down should be done already during the wipe. Here we go again. Let's see what new problem the printer invents for us. But the thing is, I also like I see there's a tiny bit of filament like oozing out. Not sure if you also see that. So yeah, this is not perfect. Quickly. So definitely like for 200, it's too hot. Way too hard. It doesn't detect it. you hear that the motor skips basically the Z motor. It's like difficult now, right? Because now it's like completely different behavior suddenly. But if this one is not sensitive enough, because we are now on the preset with the 3 on, which is preset 4. Preset 4 is already very sensitive, having the filter. There's no pressure in for the wiping. I'm less concerned right now. Like I want to it doesn't even feed in. I just want the thing to start. So we were at preset 2 where we had false positives. So now I added one with the filter and we don't have anything. We are already on preset 4. We could go to preset 7, which is like sensitive with filter. Let's try this. Now it already triggers, like I already see it now triggering just from there. So preset 7 is definitely not the way to go. Let's try preset 1, which is on, off, off. Yeah, it's with the fan. Like the problem is always the fan. You see here? Now the fan is running. You see the orange LD that sometimes flashes up here? That means the probe triggered. Now it's happening from just the fan. And that's the problem. So now we are in the preset preset 1. Which is like a threshold 10. Before we were in preset 2, it didn't work. Yes, there's a pause because it changes the stepper currency, the current of the stepper. Okay. I honestly don't have the patience anymore to like try this out tonight. I would just like call it quits for now. So the nozzle wiper works. The problem we are now having is basically that the PC probe is too sensitive or like not sensitive enough depending on the situation. So what I need to do is I just need to sit down tomorrow with a cup of tea and just trying that in all the different scenarios, which means fan on, fan off, different positions on the bed, and just see what works best. The fan is such a problem because it induces vibrations, and the vibrations are mechanical stress. So the PC probe basically has this piezo washer element that picks up mechanical stress. Vibration is a part of mechanical stress, so it's very sensitive. And you have these presets basically to change the sensitivity. There are 7 presets or 8 presets. 4 of them are without a filter, and then there are 4 with a filter for the fan, because the fan is a relatively common issue with the PC probe. And and for some reason now with the fan, like the presets with the filter, it doesn't detect when it hits. And with the presets without filter, it just randomly triggers. So it's kind of shit. So yeah, I just have to find the right one here and hope that one of them will fit. If not, you can create your own presets, but it's quite a pain. How many months did you take to build your first printer? Well, more like weeks tops. The thing is that if you build a kit, it's relatively easy. If you build your own, I think you are doing like your own design, like can take quite a while. It's just a difficult process. So it depends really what you're trying to achieve or trying to do. Well, yeah, that's for tomorrow. I hope I figured this out. Otherwise, not quite sure. The good thing is like I made sure to print all the essential parts for the upcoming build. So I'm not really like needing this printer right now. Still should work. But yeah, that's for the weekend to figure out. Well, enjoy weekend, and I'll see you next week with our new project. Until then, bye.